Okay, if everyone will take their seats, I think we can get started. Okay, I just want to do a little bit of a recap from yesterday. My name is Sue Shalal, and I'm the designated federal officer for the Science Advisory Board Hexavalent Chromium Review Panel. As I stated yesterday, all of our members are special government employees, and thereby they are restricted by ethics laws governing for government employees. The SAB works under the umbrella of FACA, which is the Federal Advisory Committee Act, where all of our deliberations occur in public. There will be minutes that are generated to record all milestones that occur during our meetings, and they will be posted on our website. All of our meeting materials are available for stakeholders and the public to view at any time. Any documents that are developed by the panel or submitted to the panel are posted on our website. And for anyone listening in today, there is a live stream of the meeting that you can find the link to by going to sab.gov or epa.gov/SAB and going to the area where it talks about meetings. And if you click on today's meeting date, you will find the link to watch these deliberations. So with that, I'm going to hand it over to Dr. Morris, who is with us virtually today. Thank you.
Thanks, Sue. Good morning, everyone. I hope you enjoyed the blossoms yesterday. It snowed here in Connecticut last night, but at least we have some basketball to look forward to this weekend here in Connecticut. I thought what I'd do is just sort of recap really briefly what we did yesterday, and mainly, especially on questions 1 and 2, to make sure that I got this right. With respect to the Tier 1 conclusions that we came to, I'm not sure I captured them in my own brain. With respect to question 1, I think our Tier 1s were that we needed to have more detail on the actual search protocols that were done, especially since the EPA guidance seemed to change through the course of the development of this document. And we needed much more clarity and transparency on the mode of action search, exactly what was done and the basis for that. Did I catch that correctly? Are those the 2 Tier 1s that we came up with?
I think that's correct. And I think that on the mechanistic search, there was a suggestion that it be informed by more mode of action considerations.
Okay.
And Dr. Van Wijngaarden, are there, I'm going to look at our synthesized comments just to make sure that there's nothing else with respect to the detailed comments.
We'll all see the write-up that you do.
I think that captured the high-level ones. Yeah.
Okay.
Can I make a comment? I thought that some of us disagreed that search should be done by mode of action.
I think that I felt that there needed to be an additional kind of like it needed to be considered in an iterative way. So an additional search considering the 2 proposed mode of actions that have been hypothesized. So not to eliminate or ignore what was done, but my suggestion was to go back as part of the mode of action consideration and look more formally at that.
So some of the key characteristics already cover the mode of action consideration. So would you like to be more specific and maybe review the search terms and suggest additional ones? Because just saying that, do this in the mode of action framework does not actually provide enough specifics as to what exactly should be done.
Right, I can do that. I think that's a good suggestion, thinking about how one looks at the small intestine, for example, how one looks at the crypts, and considering analogy with other chemicals. So I can provide those search terms later.
But mechanistic consideration is usually done overall rather than for that particular part of that particular tissue. So obviously it will be included. And also as far as comparative analysis, potency or anything like that, so I'm not aware of many, if any, risk assessments that do mechanistic evaluation actually doing this type of benchmarking. So can you provide an example? Well,
I'm thinking in the context of mode of action considerations that oftentimes, and this was in the article that was submitted by BHAT and co-workers, Sam Cohen and people from the Tox Strategies group. In that case, they looked at mode of action for 3 small intestine carcinogens who have a similar mode of action, so they can inform the others as to what's going on in a biological sense in the crypts versus the villi.
I think this is, obviously appropriate and can be done, but again, this benchmarking is not typical, and I wouldn't necessarily, recommend that as a standard approach. I think, again, comparisons are quite good, but to formally request that EPA does what, consultants have done, I'm not sure that this is where I would be comfortable, signing my name on those types of recommendations.
Would you see that being more appropriate, for example, in another section of the report?
I think as far as overall feasibility and, and describing the merits of various hypothesized mechanisms, that can be done. But again, not in terms of, well, these 3 have been studied, therefore this one should be like something else. Each chemical has its own considerations, and, treating everything like something else is not an approach that is very common. And again, I think what we need to keep in mind is that for EPA to exclude the mutagenic mode of action, they should have a lot of data to suggest that this is not a genotoxic or mutagenic agent. So just, relative potency doesn't really matter because this is hazard ID.
Yeah, I want to reiterate concern with this targeted search, that how do you target? Because we discussed already lots of information, mechanistic studies don't use word mode of action. So how do you search? So I think if we go to discussion specifically question 6, maybe somebody can say, look, these studies were overlooked, and that's fair. This study should be considered, but just blank statement, go and search some more. Search for what?
Well, I mean, I was saying being informed by the mode of action involving toxicity to the villi causing the proliferation in the crypts. Now, perhaps that's something that could be incorporated into what we're dealing with charge question 6. But I do think that that needs a second look.
Well, we need to discuss whether the actual mechanism is relevant before we recommend, because we haven't discussed question 6 yet, and how significant support for the cytotoxicity-driven regeneration is relative to other. Why should we focus on this non-mutagenic mechanism, as we discussed yesterday, not epigenetic, for example, or DNA repair inhibition?
Well, I think it's that the 2 proposed modes of action are the mutagenic mode of action and the non-mutagenic mode of action. And my concern is that I think that the non-mutagenic mode of action needs additional thought and review. and comparison with the mutagenic one in terms of the weight of evidence of each proposal.
So Barbara, the way this is striking me is that this question one is how did they conduct their search to get all the papers about
Right.
Chromium? And I think they've done a fairly systematic broad search to capture all the papers on Chromium.
Right.
Your question sounds more like a question 6 sort of thing.
Right, I think
and
that-
not that it's
Yeah.
not that EPA needs to revise how they did their search, but we need to talk about what you're talking about in question 6.
Right, I agree after this discussion, but I do think that there may be, and maybe that's where it comes in, additional literature that should be considered at that point. So
So I think it's fair for you to suggest certain papers that may have been missed. But again, your suggestion for them to reduce some ephemeral search based on mode of action is not specific enough recommendation. What I'm saying is that their key characteristics approach was systematic and already includes all of the genotoxicity, cell proliferation, apoptosis, and other mechanisms. So if you, on question 1, would like to suggest specific papers that may have been missed, I think that's fair. But just to make broad swath suggestions to do something is not informative, and the agency will not have enough guidance from this panel.
Right. I think that the papers that are not all there in this discussion are some of the ones that have been brought to our attention recently. But I'm wondering now whether that, maybe they need to be added based on the ones that have been brought to our attention recently, and then the discussion of this would be incorporated in charge question 6.
Can you provide at least one example of a paper that was not cited in the assessment?
I'd have to go back and look, but they were brought to our attention by some of the presenters from Tox Strategies, I believe.
It's great that they have provided them, but I have not heard them say that they were not actually included in the assessment. So
Right.
if the latter is true, you know, we can recommend those papers. If Tox Strategist disagrees with how the agency interpreted the same data, that's a completely different consideration.
Yeah, I think actually,
They
I think
adopt-
we might have more agreement here than it sounds like around the table. I think we have to get to question 6. And that if there's specific manuscripts that need to be considered, we can bring them up in question 6. And we just need to make sure that the search was broad enough to include information on intestinal modes of action.
Right.
Okay, before we go any further, can I suggest that folks put their tent up when they want to speak? It will help our folks with the AV to make sure that they're pointing the camera at the right person. And also, I don't know if it would be helpful for the panel to hear from EPA about their strategy for looking at MOA and maybe clarifying exactly what they have done, and if you have any additional thoughts about
Right.
how they can improve that, you know, that might be a helpful way to move forward. So, Catherine or Chris, if you guys want to say a few words?
I mean, if it's determined that you want to continue to discuss this now versus later, but it's specific to the search, the literature search. So, I mean, I can just very quickly say that, you know, all of our assessments start with the broadest possible literature search that we can make it. It's only, the only target with the search strings is Chromium and toxicology, relevance to toxicology. And it's more excluding terms to eliminate things like engineering studies or geological studies, right? So then we end up with a huge pile of studies, and those are manually curated into piles for, you know, PICO or non-PICO studies, which does mostly focus on, you know, it ends up that because our assessments do have a lot of animal and human data, those do tend to focus on studies that will be, you know, presenting data that's most amenable to dose response. In the future, that may not be the case, so we don't want to say, you know, strictly all PICO studies will all, you know, will never include mechanistic, because someday in the future, that may be all we have. But right now, it's true that, you know, the human and animal studies identified by PICO are those that will be presenting data amenable to dose response. And then everything else is then categorized under supplemental evidence. And then if it does go to excluded, that's really anything that's clearly not relevant. And so for everything that, or, under pharmacokinetic studies, those are separated, and then anything with mechanistic value, that could be human and animal studies, and that could be, and then everything in vitro. So everything, so this is 1,600, I believe 1,634 studies, and they're all in HAWK, they're all tagged, and so far, I've looked at the list that, for example, Dr. Costa presented, all of those studies are there. It's just that we had to prioritize, and we can't cite every mechanistic study in the assessment. You guys would not like it if we did that. It would be, the document would be 3 times longer. So what we do is we, provide all of that information. You can see all the studies in HAWK, and then those that we prioritize for each health effect, those are summarized in tables in the appendices, and each appendix section starts with an explanation of how we prioritize those studies. And so if your study, if you're not finding it in HAWK or HERO, which, they're, symbiotic, HERO is our literature manager, and then HAWK is where we keep most of our data and information on literature search and screening. If it's in neither of those places, then we're happy to put it there. And humans make mistakes, so I'm sure that there's going to be a handful of mechanistic studies that aren't there. But certainly anything that's related to something that's in a target tissue would have been, that's very important to identify, and, I believe we got everything. So thank you very much. And just let me know if you have any other questions.
I guess I just have one overarching question. Perhaps this isn't really part of the search, but it's relevant in a way. How do you consider framework proposals, such as the work by Bubis or the IPCS, in terms of mode of action and?
Well, as you correctly identified earlier, the cancer guidelines were, born out of that process with IPCS, and so we use the cancer guidelines. And in that, there's a transition between identifying mechanistic studies, then prioritizing those based on, criteria that we determine, in this case, usually anything in vivo and anything in vitro in human cells. That's not always the case. It depends on the specific mechanism. But these have been organized originally by the key characteristics of carcinogens. And then once we have all of that information, we have like lists of studies in each of those categories. Then we identify key events that are relevant to cancer that aren't necessarily, some of them do coincide with key characteristics and some of them don't, because key characteristics are meant, those are piles of different mechanisms. Many of them, especially key characteristic 10, there are multiple mechanisms in that one. So it's more useful to identify key events from those. And then once we have key events identified, then we look at the prioritized evidence and summarize those. And those are all summarized in the mode of action section. And then that's where the mode of action framework comes in, where you identify all of your human and animal, the tumor evidence, the mechanistic evidence that's relevant, and pull that together. There's a table that summarizes evidence for each identified key event at the end of the mode of action section. And this is, again, mechanisms, not modes of action. These are all mechanisms that are thought to be relevant in the pathway to cancer. And these are all, there are many of them that, all play a role.
Thank you.
Yeah, thanks.
Okay. I think this has been a valuable discussion, and look forward to seeing how you pull all this together when you write up this part. I think we'll return to some of these issues when we get to question 6. With respect to question 2, I have that the tier 1s are we need to have better explanations of some of the reasons for the exclusions of the studies, and the report wasn't really consistent with respect to indicating that. Some tables included studies that were excluded and others did not. And that what we actually decided to do was defer any conversation on concerns on confidence assignments with specific papers till we got basically to question 6. Does that sound about right?
I think that's correct. I mean, there were some errors that warranted revision in terms of how information was presented in the table, not in terms of interpretation,
Yeah, right.
but that will be straightforward to address.
Yeah, okay. Okay. Hearing no one leap to the microphone, I think actually I'm pretty clear on all of the target organ stuff that we've done so far. There certainly are some recurring themes about uncertainty factors and benchmark dosing and being more comprehensive. But I think we'll return to those when we get to questions 4 and 5. So if there's no burning issues of those other members of the panel, I think we can move on to the next target organ. Okay, seeing none. Yeah. Easy to say because I can't really see you guys around the table. We'll go on to the hematological target, and we'll follow the same approach where the lead discussant will sort of summarize and we'll give the individual commenters the chance to pipe in and then everyone else to pipe in. So I believe it's back to you, Dr. Lash.
Yep. Yeah, so we've done 5 out of the 9 target organs already. We did GI, respiratory without and with nasal, and developmental, and what was the other one? Oh, and liver, hepatic. So now we're on to hematological. I just want to mention, and some of this will come up in the remaining 4 target organs, that one of the, I think, the themes for tier 1 or tier 2 suggestions or recommendations is validation of model organisms. So, making it clear whether the rat or mouse is the best model and the basis for choosing them. That was a recurring, I think, comment. So anyway, let's go on to hematologic. So I'm going to read from my computer because I can barely read that. So it says, evidence suggests that chromium-6 may cause hematological effects in humans given sufficient exposure conditions. This conclusion is based primarily on moderate animal evidence from high and medium confidence subchronic and chronic studies in rats and mice, reporting consistent dose-related and coherent findings at 22 to 90-day exposures. However, the magnitude of the collective effects decreased by 12 months, with many findings returning to normal or near normal levels. Organ system-specific reference doses were derived based on short-term hematological effects because factors demonstrated a credible concern for greater toxicity in a susceptible population and life stage, such as individuals with iron-deficient anemia and pregnant women who are susceptible to developing iron-deficient anemia. Please comment on whether this conclusion is scientifically justified and clearly described. And then the second part is that a point of departure from NTP 2008, a 2-year drinking water bioassay in rodents was selected to calculate an OSRFD of 0.01 milligram per kilogram day based on decreased hemoglobin in male rats reported at 22 days. A composite uncertainty factor of 10 was used to account for intraspecies and animal to human uncertainties. A subchronic to chronic uncertainty factor was not applied because this effect was observed to ameliorate with chronic exposure. Please comment on whether the selection is scientifically justified and clearly described. And so I received comments, the reviews were Dr. Costa, Dr. King, and Mr. Haney. So for the first part, I think one comment was that the hematological toxicity and the approach was appropriately explained and presented. Another comment was that sort of explaining the rationale for using the sort of the short-term results because of the amelioration of effects as you go to 12 months. But it was felt that this was still an important effect, and I think, however, there was some concern expressed about the, I think, 22 versus 90-day data, which one to use. Then there was also an issue, and this came up, I think, in an earlier target organ, that there were 6 excluded studies that were rated as uninformative, and those should be included in Table 330, similar to what's done in other cases. Let's see, that's part 2. And there was also, and there was, I think, some concern expressed by another reviewer about, I think, the certainty with which the language in terms of differentiating a may-cause determination for hematological effects from likely causes for other types of effects. And so there was concern about, since here we have, again, slight human evidence and moderate animal evidence. So those were the first part comments. In the second part, one reviewer commented that the assessment, the OSRFD, was appropriate and the uncertainty factor was explained and justified. Second reviewer thought that that there was some lack of clarity with the exclusion of certain of the uncertainty factors, and that needs to be more explicit. Let's see. And then again, I think the comment about the choice of animal model to use and how rat versus mouse, and why the one is better than the other in terms of exhibiting similar hematological effects in humans. And there was also, I think, concern expressed about comment made that that without evidence to the contrary, human relevance of the animal findings is assumed. So there's a concern about what that sentence implies. And also a comment similar to the previous reviewer about the uncertainty section not really adequately addressing the aspects of the uncertainty, particularly with regard to the animal model and whether a similar dose response may be expected in humans. And there was a tier 1 suggestion about, again, similar to in other sections, about justifying the animal model, and if not, making a statement to that effect, that the species selection is based on policy if you can't justify it or provide evidence that it's the better species. So I think that was it, generally, the gist of comments on the hematological. I think the key issue with the hematological effects is that it in some respects is different from the other organ effects in that the short-term, it's really short-term effects because they seem to partially resolve with time and in terms of the mechanism, but it was felt that because of the likelihood of susceptible populations, that it was a valid that had significant risks, such as iron deficient anemia, pregnant women who are prone to that. So it was a different, but I think the issues in terms of explaining the uncertainty factor and the animal model. So I guess if any of the reviewers, commenters on this wanted to elaborate, or if I got anything wrong. Either Dr. Costa or Haney or Dr. King.
I'm watching my colleagues online to see if either of them are going to make the first move. First of all, I guess the term from the chair, recurring theme, comes to mind. On this section, I do think there's a lot of consistency. Some of the things that Dr. Beck mentioned about clarity of the reporting, consistency, and what makes it into a table, things like that, those are all addressable. I wanted to speak just mostly in support of the temporality analysis and caution from even falling too far into that idea of resolution of effects. That term resolve works in hemostasis research, but not necessarily to the benefit of subjects or patients, or in my case. You know, this is probably the closest to content expertise that I get during this review, is around resolution and balance of toxic issues in plasma in particular. And so I think that's a really interesting one. I do encourage that maybe I'm even bringing up an issue that's not a point of concern, but we did see some comments that people weren't sure about the temporality, the selection of a criteria based on a subchronic interval. And I think that's actually really important in this case because, well, for two reasons. One is, again, that subchronic exposures can often lead to very bad conditions, particularly when we're talking about oral routes of exposure. And then I would, how to put this? Yeah, I think that there's also a consideration around the uncertainty factor. I know we're supposed to be saving that for a later question. As far as extrapolation, this does seem to be treated separately and differentially from other organ systems as far as what the inflation is. And so that's one of the reasons I asked but then didn't pursue a question yesterday is it's not really clear how that's applied. Anyway, the final thought is, as far as that term resolve, I think that's fine as long as we make it clear that there are, in hemostasis, often downstream effects from compensation that leads to those things. So that's not necessarily a positive finding. And it sort of reads that way as if the effect goes away, and we know that's not the issue. So I just wanted to add
I
that.
think that was more my word, that I think the document talks about. Is it in there? Because I thought it does say about amelioration.
Amelioration,
yeah,
that was
is
the
what
term,
they say,
right.
which doesn't mean I guess resolve is a little more of a complete return to normal.
Right. But that was, I mean, I think overall, like I said, I did make some more comments that I'll be adding, apologies to the lead, on very small recommendations, again, mostly around clarity. I think it's an important area, and the human research on this is, I mean, with respect to the authors, inadequate, right? As far as the consistently low effects, and I went through and actually read all the cross-sectional studies. The one attempt at measuring exposure through inhalation route was the negative study. That's not that surprising, except that it was probably the best approach at measurement across all of them. There is sort of a borderline cross-sectional / ecological study that's included around residents, but we know we have to default to that in many of these epidemiologic studies. The route, I don't think route or mechanism, sorry, I'm not using that term in the way that other people do. The measurement of exposure is really struggles in those human studies, so we need to make it really clear that this is slight evidence, which they do. Mm-hmm. Actually, I think undermined even that, this is inadequate human evidence. Yeah. Okay, that's it.
And one point I just wanted to make that I forgot is also the comment was made in discussing the uncertainty factor. It was noted that it's probably not much of a concern because the OS RFD is much higher than that for other organs, so it's not going to affect really the overall RFD or the choice of RFD. Oh, Mr. Haney, you have a comment or question?
Yeah, just to very briefly add on, I think, to what was just said, to sort of state the obvious that a chronic tox factor must also be protective of adverse effects which occur with shorter term exposure, such as developmental effects due to exposure during a critical window of development, or, in this case, hematological effects as well. I think it's supportive just to say that and state the obvious that chronic tox factors also have to protect against adverse effects that may occur with shorter term exposures.
Okay. Anyone else have comments or questions regarding the immune or the hematologic effects? No, I guess if not, should we?
We can move on. Yep.
Okay. All right. So next we'll move on to, I guess, the next slide, please, which is 3G, which is the immune effects. Okay, so if you could come in advance to the next slide. It's actually a much shorter one. Anyway, evidence suggests, I'll start reading until we get the slide up. Evidence suggests that chromium-6 may modulate the immune system in humans through both stimulatory and suppressive actions given sufficient exposure conditions. This conclusion is primarily based on coherent evidence of effects on ex vivo white blood cell function across human and animal studies, antibody responses to T-cell dependent antigen measured in animals, and reduction in host resistance to bacterial infection reported in animal studies. However, confidence in the evidence was reduced because some of the studies are low confidence and reported findings often differed across studies. No reference values were derived for this system. Please comment on whether this conclusion is scientifically justified and clearly described. And I think we had the same, I received comments from the same three reviewers, Dr. Costa, King, and Mr. Haney. One comment, about noted the low confidence of the studies in the literature, and that there's some seemingly contradictory findings, but that so the document explained this well, and the conclusion seems justified based on the available data and publications. Another comment, so notice that really the animal study evidence is weak, and so basically, there's a number of studies, it says, that are that provide some inconsistent subclinical mechanistic measures of immunological function. At times, the data in some studies give results that are opposite from the other studies, and that seems to be based on route of exposure or duration. So some of I think the question came up about some of the descriptors that are used, such as limited versus very limited evidence of effects. Then also a comment about excluding some studies that are, including 4 human studies that are that seem to need more characterization. Although they were deemed uninformative and excluded, they should be better explained and characterized, and rationale for their exclusion should be clearly indicated in 2 of the tables. And let's see. So I think overall, there were no Tier 1 recommendations, but a couple of Tier 2 about really characterizing the evidence. And to more accurately, I think, reflect the limited evidence that's available, and provide better rationale and listing in the tables for the excluded studies, which included 4 human studies. So that was the extent of, and again, there was no calculation of a OSRFD value.
So can I make a comment?
Yes, please.
Chromium 6 is very bad at causing contact dermatitis, allergic reactions, as is nickel. And this usually happens mostly on the surface of the skin. But again, you know, I think we should mention something about that because it's kind of important. And, you know, it happens with jewelry and all kinds of things that have any chromium in them. And a large percentage of the population, particularly women, actually, are susceptible to contact dermatitis from nickel and chromium.
So that would be like, I don't know, a tier 1 recommendation that this needs to be added, and maybe if you could add those to revised comments, that would be great.
Yeah. Okay. All right.
I don't know, open a ball of wax, but how did this get missed?
So they actually, in the report, and we can call them up to discuss, actually, in the report describe why they left that.
Okay, as long as it's there.
They did mention it, and then they gave a reason for leaving it out. What was the reason?
I'm going to invite them to do that directly, so I don't just parrot their words.
No, I mean, it's a strange reaction because actually, if you ingest it, you probably don't have much allergic reactions. Okay, I mean, it's mostly on the skin, mostly if you get on your skin. That's really, and it's a straight, you know, that's the way it happens for humans. I'm sure mice and rats are similar. Actually, no, I'm sorry, mice and rats don't get contact dermatitis from nickel or chromium. So, in fact, in order to study this, they actually cloned the human gene and put it in a mouse. And then when they gave them chromium or nickel, they got contact dermatitis. So the mice and rats don't have what humans have in terms of the ability to launch an allergic reaction to chromium. So there's no animal model for this.
Okay.
Okay, so we'll hear from Dr. Alan Sasso from EPA to explain why they left that out.
So I briefly explained this in the intro talk the other day, and it's probably explained a little bit more in our protocol and some preliminary materials, but dermal effects were just generally considered out of scope from early on in the assessment development process. And, you know, we acknowledge that it causes contact dermatitis, and is probably briefly mentioned in the immune section, but there was no agency need. Yes. Yes, the agency need. Yeah, there was no agency need for a program or a regional office need for a dermal assessment. So that was the primary reason.
I'm sorry. I'll put it like.
Yeah, I mean, if you happen to work around chromium, you know, like working on cement or something like that, you actually can't work around it if you have this, if you're allergic to it. So it is a pretty important thing if you happen to be allergic to it. But and some of these reactions can be really bad.
Okay, Mr. Haney?
Yes, I just want to comment that, you know, Chrome 6 contamination of groundwater or drinking water is not uncommon. And for people that are affected, you know, as regulators, both EPA and TCQ can tell them, look, you know, you can't drink your groundwater. So, but then the next question is, well, what can I use my groundwater for? And, you know, for all practical purposes, you know, they very often ask these sorts of questions. It's totally understandable. And so they want to know, for example, if they can take a shower in it. And this is a question that, you know, both TCQ and EPA has to answer. And so, and it concerns, you know, whether the concentrations of Chrome 6 in the water are sufficient to induce some types of dermal effects. There's other components as well, but I think it is a very important question. In my experience, it's a very common question that at least EPA Region 6 and TCQ has to answer, because again, it's not uncommon for unfortunately for folks to have groundwater or drinking water that's impacted by Chrome 6, and they want to know if they can, for example, shower in it and bathe in it, and a consideration of potential dermal effects is important in giving them sound advice. And so while it may be quite uncommon for an IRIS assessment to address something like that, if it could, that would be great.
Thank you, Mr. Haney. I just want to suggest that perhaps it would fall into the tier 3 comments, that it would be a challenge to do that de novo, but it does seem like it's an important issue for EPA to consider, particularly from the groundwater perspective. And I just want to note that Dr. Post has been patiently waiting to make comments, so I turn the chair over to Dr. Post.
Barbara. So I'm glad this was brought up about the contact dermatitis, because I don't know why. I didn't even think of it till it was just brought up, but these toxicity factors are not just for water, even though that's what's mainly being discussed here. In New Jersey, it's been addressed, and now it's not as it's not on our forefront right now because we've addressed the sites, but we had and have a huge issue of chromium contaminated soil where urban areas were built on fill from chrome processing, and it's not the groundwater specifically. A lot of the work was on developing health-based soil standards for oral exposure and inhalation exposure to soil, and also actually our soil standard for chromium was based on contact dermatitis. Years ago, my colleague, Dr. Alan Stern, who retired, was the lead for that, and wasn't involved with that work. Other toxicologists worked on it, but they did it, and Dr. Costa, I think, is very familiar, with that too, what we did. They did a tremendous amount of work, and I think even sponsored research studies to develop information on the doses that cause contact dermatitis. Maybe, I don't know. So that wouldn't be an oral toxicity factor or an inhalation toxicity factor, such as IRIS presents in its assessment. It would be, I guess, a dermal toxicity factor, the concentration that can cause it in sensitive individuals, but it at least has to be acknowledged and discussed in the IRIS document, because it's very important for addressing environmental contamination from chromium. Maybe, I don't know if it can be caused from showering. I'm not familiar with that, but the IRIS assessment will also be used for soil standards.
Okay, I think actually we've got consensus, don't know exactly what the wording will be, but that certainly EPA needs to reconsider the exclusion of contact dermatitis and perhaps include that. Right? Would that, are people comfortable with that?
Yeah.
Okay, at least we'll get it down on paper, and then EPA can do as they see fit. Are there other comments, concerns, questions for the good of the fraternity? Okay, then we can move on.
Okay.
Dr. Lash, you're still on the hot seat.
Yep, got two more. Two more relatively short ones. So the last two are reproductive male and then reproductive female. So 3H is reproductive male. So evidence suggests that chromium-6 may cause reproductive toxicity in humans given sufficient exposure conditions. This conclusion is primarily based on coherent evidence of effects across human and animal studies. Decreased testosterone and decreased sperm quantity and quality were observed in both human and animal studies. However, interpretation of this evidence was limited because most studies that observed these effects were considered low confidence, and there was inconsistency with higher confidence studies. No reference values were derived for this system. Please comment on whether this conclusion is scientifically justified and clearly described. So the reviewers on this that I received comments from were Dr. Beck and Mr. Haney. And so, so comments, so I guess there was, the main comment had to do with the conclusion saying that there's evidence of an association between chromium-6 exposure and male reproductive effects. But it's described as the evidence in humans is slight, and it's slight in animal studies and mechanistic studies. So there was a concern about how this was expressed, that the evidence might be suggestive rather than the way it's expressed in the document. So maybe it's suggested maybe may potentially is a better way to phrase this. Other comments had to do with, again, there was about the weight of evidence and scientific literature, and that this is clearly described in the text. So I think as terms of recommendations, the only recommendation that I pulled out was, I guess, considered a tier 2, which is to clarify how the conclusion of the suggestive conclusion was developed given sufficient exposure, since the evidence is described as slight. And so that seems to differ a bit from other target organs, and slight in both human and animal studies as well as mechanistic studies. Okay. Anyone like to comment? Who are the reviewers? Or?
I think that describes the comments I've reviewed accurately.
Mr. Haney, did you want to add anything or come? Okay. Anyone else have questions, comments? So again, I think there's not a lot of strong data, so it wasn't, no OSRFD was calculated.
Okay. Let's move on.
Okay, so the last target organ, which is 3I, is reproductive female. So the charge question is, evidence is inadequate to assess whether chromium-6 may cause female reproductive effects in humans. Although an association with female reproductive toxicity was demonstrated in a single low-confidence epidemiology study and a series of low-confidence animal toxicology studies, effects were not observed in medium or high confidence studies aside from a moderate decrease in maternal body weight. No reference values were derived for this system. Please comment on whether this conclusion is scientifically justified and clearly described. And again, the reviewers were Dr. Beck and Mr. Haney. So one comment is that the conclusion seems appropriate, that based on really inadequate evidence. And other comment is also basically that I guess there were some comments that Mr. Haney made about some corrections for certain factors, like but he said overall the weight of evidence decisions clearly described in the text and the integration of the evidence. So again, there was no calculation of OSRFD for this, and no specific recommendations. Anyone like to comment?
I'd like to say something.
Yeah.
So this is one of the most sensitive toxic endpoints you could possibly imagine, is birth defects in females, and it's often used to try to figure out what's the safest dose that you can have of this chemical in drinking water, for example. And so it's a very, obviously very important when you have a birth defect. And I think it's really important. And I don't know. It doesn't seem like we're taking it as serious as we should.
Isn't the problem that there's no data, right?
I don't, I didn't do a literature search, but I mean, it's, I'm just, yeah.
I'm wondering if EPA could clarify whether developmental effects would cover, where I think birth defects would fall within the developmental category, but perhaps EPA can clarify that.
Oh, I'm sure it does. Yeah.
So
It's,
it wouldn't be dealt here under reproductive.
Right, yeah, I think that the document does pretty clearly distinguish between what are considered developmental versus reproductive effects. But I mean, if the EPA wants to comment on that further, because it's certainly an important point.
so if they're just talking about this as an inability to reproduce and not birth defects, that's
Right.
one thing. But I think they're both related to each other, obviously, and the birth defects happen very easily and very low concentrations. I don't know. I think it's a pretty important part of the toxicity of chromium and other teratogens, whatever you want to call them.
Yeah, but you have to make the decision of what bucket to put it in. And so I think EPA has decided it goes under developmental. They could, in the repro section, they could put a comment that the developmental effects are discussed, in the previous section. That would, just to emphasize that they are considered. It's just not in the reproductive section.
Okay.
Okay.
My recollection and impression is that they did spend a fair bit of time making the distinction between reproductive versus developmental.
Okay.
Yeah.
Okay. Yeah, certainly it was my impression that was under developmental as well. Are there other comments on this part?
Dr. Chen has some comments.
Yeah, actually, for the developmental effects, there is structural alterations, mainly talk about ossification. Certainly, that's actually considered under developmental, not only skeletal ossification, but there is not much actually on the basically birth defects, but that is probably in the literature is not there yet.
Okay. Okay. I mean, we were comfortable with the developmental section when we were there. So.
Yeah, and there is the OS RFD is calculated for developmental, and there's quite a lot of meat in that section as opposed to the reproductive, which there's less in the way of clear studies and high confidence or medium confidence studies.
Okay. Okay. Any more comments? All righty. Thank you, Dr. Lash. You had a bunch of them.
2 hours ahead of schedule.
I know. It seems a little early for a break, but it seems like a convenient time, right, to take a break before we launch into question 4. So hearing no objection, should we take a 15-minute break now and then we'll tackle question 4? So we'll be back at 10:15.
Okay, we're recessed until 10:15. Everyone, if you would please take your seats. We're about ready to get started. Dr. Morris, I'm going to hand it off to you.
Sounds good. Thank you. So we are moving along and we're on charge question 4. And I believe the lead discussant is Dr. Post.
Right. Thanks. So I'll read the question. EPA used benchmark dose BMD modeling to identify points of departure for the following chromium-6 induced health effects observed in rodents: respiratory, gastrointestinal cancer, and non-cancer, and hepatic. Are the modeling approaches used selection and justification of benchmark response levels and the selected models used to identify each POD for toxicity value derivation scientifically justified and clearly described? So Dr. Beck, Dr. Rusin, and we were assigned to the question, and Dr. Haney also responded. And I'm going to give a summary of the responses, and they can, Dr. Beck, Rusin, and Mr. Haney can add on and clarify and add more details if they would like. So as far as myself, in order to address the question, I reviewed the section in the main document on dose response analysis, section 4, appendix D on the dose response modeling in the supplemental information document, and also the model log files for the IRIS toxicological, the model log files for this review that are available online. I reviewed the BMD modeling and the selection of BMDLs for non-cancer and cancer effects of oral exposure and non-cancer effects of inhalation exposure that BMDLs were developed for. And even though it wasn't specifically asked in the charge question, I also reviewed the rationale for concluding that a no-L or low-L should be used as the POD because the BMD modeling was not supportable for some of the endpoints. So for both the non-cancer and cancer effects in the small intestine and the non-cancer systemic effects from other ones from oral exposure, I agreed with the EPA approach for converting the dose ingested by rodents to the HED human equivalent dose. This, just to summarize, I'm not sure if this has been talked about yet at this meeting. It was kind of complicated. The internal dose in rodents was first determined by determining the dose that escaped reduction in the stomach using a PK model, and then it was adjusted by the body weight to the 3/4 ratio, the body weight in animals to the body weight in humans to the 1/4 power to account for interspecies differences in the volume of the small intestine. After that, the relevant human equivalent dose was back calculated from the human internal dose with another model, the human PBPK model for human reduction of chromium-6 in the stomach. And I agreed with that, but I also agreed with their rationale for using the lower 1% value of the administered dose from the human model for non-cancer effects and the median, the 50% value for carcinogenic effects. But it wasn't, at least to me, it wasn't intuitive that both the PK model and the body weight 3/4 adjustment should be made, and I don't think the rationale was clearly explained in the main document in section 4.2.1.1 on that topic. So I suggest that the explanation should be expanded for why both adjustments are made so it's clearer to the reader. And I found a very clear explanation in the appendix, in Appendix C, that I noted the page and everything in my comments, and I suggest that that explanation be repeated in the main document so the reader can understand it when they're going through. So as far as the benchmark dose modeling itself, I agree that EPA followed their technical guidance for modeling of each effect. I agreed with the benchmark responses selected by EPA for each effect. I agreed with their choices of the BMD and BMDL when the modeling provided multiple options and that they justified those choices. I also agreed that using a no-L or low-L instead of a BMDL as the POD for other effects is consistent with the EPA guidance and was justified. I also provided 12 additional specific suggestions regarding the need for clarifications and minor corrections, and they're in my comments. I don't think I need to go through them here. They're clarifications and minor corrections. Dr. Haney provided extensive comments, and I'll get back to some of his other comments later, but as far as what most of the BMD modeling presented in the draft document, he also agreed that the modeling approaches, selection process, and BMR levels were scientifically justified. He had other comments that I'll get to later, but he also specifically suggested that EPA reconsider the use of BMD results rather than the low L to no L approach for the POD for diffuse epithelial hyperplasia of the duodenum in female mice. Dr. Rusin's comments, and I hope he can clarify them a little after I'm finished. He stated that the draft in the main section doesn't clearly indicate the types of PODs that were used for different studies in figures 4.3 and 4.7, and that should be added. He's commented also that the BMD model fits were not included in the appendix, only the summary tables. I'm not sure if the information he stated was missing in the appendix is found in the additional files that aren't part of the documents. But he can clarify. He also stated that there's orders of magnitude difference in the PODs based on different models that have similar statistical parameters, and that it can't be determined how well the data actually fit, and to just use the lowest AIC and the highest p-value quote, blindly, and that the, quote, winning model should be shown in either the appendix or the main document. Dr. Rusin had other comments about studies that were not selected for BMD modeling, such as the Thompson et al. Studies, and I think it might be better to transfer that to charge question 3, as we were talking about yesterday, because to move those comments to part of the comments on another charge question, because this charge question isn't really about the study selection, it's about the actual modeling. We talked about this yesterday. He also had a comment on the uncertainty factor selection and gave an example regarding modeling of ALT in subchronic studies in two different studies. That might also perhaps be moved to the next charge question on uncertainty factors. And another comment about ALT data from a 90-day study, that there was it seemed like there was a pretty severe effect and it was, he can clarify, but his point was that even the low L divided by 10 might not give the true effect level. I think these comments might be better transferred to be synthesized in the comments on other charge questions. Dr. Beck didn't really provide comments on the BMD analysis itself, but she suggested that BMD analysis using diffuse hyperplasia or potentially transcriptional changes in the crypt cells be performed as part of the mode of action analysis for cytotoxicity regenerative hyperplasia. Mr. Haney also had extensive comments on the choice of the dose metric for the gastrointestinal effects, both cancer and non-cancer, and the choice of the model for those effects. And I'm giving a short summary, and he can expand on it if he would like. For the non-cancer effects, he noted that he had published in 2015, he had a publication that modeled this endpoint on the basis of absorbed dose in the duodenum, and that this approach for BMD modeling should be considered instead of the current approach. And he noted that EPA considered the results of the BMD modeling for this effect using their approach too uncertain to use for the POD and used the Lowell instead. And for cancer effects, in a kind of similar comment, Mr. Haney performed exploratory BMD analysis with EPA's BMD modeling software and suggested that target tissue absorbed dose should be considered by EPA as the dose metric, and also that models that appear sublinear in the lower part of the dose response curve should be considered because they may provide a better fit for the tumor dose response than the multi-stage degree 1 model that EPA used, and that the sublinear dose response may better reflect or may be present, and this would be a better model because there's decreasing fractions of the dose are absorbed by target tissues as the dose decreases. So that's the summary of the comments, and I hope people can expand on them.
I think you summarized my comments completely.
Does Dr. Ruslan or
Dr.
want to
Ruslan.
chime in?
Yeah, so yeah, this was a good summary. I think what we will need to do, we'll need to transfer some of the study selection to section 3 and my comments on the ALT as well, because I personally don't think as a liver toxicologist that ALT in subchronic or chronic studies is actually informative, especially because it was elevated and non-monotonic also in some of the high-dose studies, indicating that there is severe damage to the tissue, and it's just not the endpoint that should be used for modeling, because there's histopathology data as well, which is much more sensitive. So I'll revise those comments. My biggest challenge with comprehending this very important part, which is the point of departure derivation, was that you really had to labor to find the actual BMD data. And there's a main document, there's an appendix, and there's other stuff. And I understand HAWK and HERO being repositories of information, but appendix should include all of the data. One should not actually be on a quest to find this information. And while the complete details of all the different models can be in the section in the appendix, the main document should contain actual graphs for 1 or 2 models that have been the basis for the POD derivation. So one can actually understand how well that particular model fits the data, rather than just looking at these AIC and p-value numbers that are quite abstract. And again, because there's such a big difference in the POD range, depending on slight differences in the archaic information criterion and the p-value, the agency should really do a better job in providing the actual graphs in the main document. I understand it will add a couple of pages, but what's a couple of pages and a couple of hundred pages? So for transparency's sake, I think it's very important.
I was going to say, I agree that more about the BMD modeling should be in either the main document or the appendix. I don't think I wrote it in my comments, but in order to review the BMD modeling, it's in files that are linked, and I think I had to write to EPA because I couldn't figure out where they were. Maybe I should have been able to, but they're not part of the documents, and I think it would be good if there was like some of that was in an appendix in the actual document or appendix section too.
Would you guys say that's a tier 1 comment?
Yeah, I think because this is really presentation and transparency, so.
Yep, seems like it to me.
Dr. Roussin, you had a comment also that you didn't just go over about the uncertainty factor, which I didn't really understand your point. Maybe it's probably just me, but maybe could you talk about that now or when we do the next charge question?
Sure. The uncertainty factors for some of the effects may need to be justified a little better because, you know, these factors of 10 or 3, they make a big impact on the ultimate RFD. And for some of the uncertainty factors of the database, for example, was the biggest concern of mine, where the database consists of studies of low to medium confidence, but it's an effect that is absolutely well established. So portal of entry effects for chromium and other carcinogens are indisputable. So applying an additional uncertainty factor is unwarranted in that regard. Now, so that's the type of a comment, and I'll try to clarify it.
The example, because I copied your comments into my summary, even where you said that you had a table copied where you said there was a 10-fold difference. I think it's because one's a no L and one's a low L in that particular example that you copied into your comments.
That is correct. Yeah,
So
the
I
one.
didn't really understand what you were questioning on that particular one.
So you are correct. I'll rephrase these comments to suggest that ALT should not actually be used at all as an endpoint, because in subchronic to chronic studies, this type of a blood biomarker is less reliable than the actual histopathological changes.
Okay, thanks. Dr. Haney, do you want to expand anything on my summary? Mr. Haney, sorry.
Yes, yeah, and Dr. Post, you did an excellent job on that, so I commend you for that and appreciate it. Most of my comments had to do with the dose metric and the choice of the dose response model. And so I want to cover a little bit more of this again. So regarding choice of the dose metric for the BMD modeling of diffuse epithelial hyperplasia of the duodenum in female mice, like you said, Dr. Post, there was a study wherein one of the things I did was model that based on duodenum tissue absorbed dose, which was mean added chromium per kilogram tissue, which is an available dose metric that's more closely causally associated with the adverse effect. And so I consider it a more predictive and desirable dose metric. I covered this yesterday. The log logistic and dichotomous yield models provided adequate fit to the data confirmed by visual inspection. The BMD value showed the BMDL value showed good agreement with their BMD values. But the point I'm trying to make is that unlike the EPA BMD modeling results, the modeling using target tissue absorbed dose as the dose metric didn't have any of the problems that EPA had when they used the dose metric in the draft assessment. We did not have these very large differences in the BMDs and BMDLs. The modeling that I conducted based on target tissue absorbed dose seems to meet all the modeling criteria in section D11 of the draft assessment. And again, BMD is an approach that considers all the data as opposed to the low L approach. And the modeling was based on a dose metric more closely causal related to the toxic effect, which is target tissue absorbed dose. So yes, I'd recommend that EPA explore that approach. For cancer effects, what my comments say is that target tissue absorbed dose is the most relevant and direct determinant of excess risk. And then I have a couple of figures that I provided in my comments, which show the relationship between the mouse small intestine absorbed dose and the tumor data, and there appears to be good agreement there. And so I say that based on the consideration of target tissue absorbed dose being the more direct determinant of excess risk, that EPA may find that target tissue absorbed dose provides a better fit to the data, at least in some cases, and a better fit to the tumor data, despite the potential uncertainties that they outline in table C10 of the draft. A better fit to the actual data would increase confidence in the use of the target tissue absorbed dose as a preferred dose metric. I then go on to provide a figure that shows how target tissue absorption data indicate that the dose fractions absorbed by target tissues decrease as doses decrease below the draft oral slope factor POD dose. These dose fractions appear to appreciably decrease below the draft oral slope factor POD dose. Going down, my figure shows the dose at the federal MCL. And so what I conclude from this is that linear extrapolation of target tissue absorbed dose below the POD overpredicts a target tissue absorbed dose. I provide some example figures for the duodenum specifically, and also talk about target tissue absorption by all three tissues, the duodenum, jejunum, and ileum, and it results in a similar overestimation at the MCL, being that linear low-dose extrapolation overpredicts the tissue concentration, therefore excess risk at the MCL by around 4-fold. So I state that because target tissue absorption data indicate that the dose fractions absorbed by target tissues decrease as doses decrease below the POD, sublinearity should be expected at lower doses. I provide a figure to help illustrate this. And this all has to do with what models should be considered. I say that target tissue absorbed dose should be considered as a dose metric for modeling, and that models that appear sublinear over the lower part of the dose response should also be considered for selection, as they may better reflect the sublinearity in dose response expected based on the decreasing dose fractions absorbed by target tissues at low doses, and also provide better fit to the data. Then I cite EPA guidelines that acknowledge that dose response modeling is largely a curve fitting exercise. And say that both the target tissue absorption data and lack of scientific consensus on the CARC MOA suggests that other models than the one selected by EPA should be considered, and that better fit by other models reflect a better fit to the reality of the actual dose response data and the underlying biology that produced those results. And these models might also appear sublinear across lower doses and more accurately reflect the actual dose response data, and perhaps being more consistent with the expectation of low dose sublinearity. And then again, cite EPA guidelines, the EPA cancer guidelines that allow for different model fitting approaches for tumor data when justification is provided. So like Dr. Post said, I did explore some BMD analyses. First, I just did so with the same data that EPA used to see if EPA software suggested a different model than EPA chose. And so, yeah, I ran the male mouse data and the female mouse data and provide the figures, and note that EPA software suggests different models than EPA selected, and those recommendations by the EPA software was based on better model fit, that visually the models fit better than EPA's selected model, and they appear sublinear over the lower dose range, which to me is more consistent with what's expected across the lower doses given the target tissue absorption data that I talked about before. But I didn't recall any explicit discussions in the draft assessment as to why these types of models should not be selected. And have a suggestion that if you're going to reject those better fitting models, there needs to be such a discussion in the draft. Then I explored some EMD analysis with target tissue absorbed dose as the preferred dose metric. And although I'm not a PBPK modeler, I estimated those based on the data in hand simply by interpolation. Of course, PBPK modelers such as Dr. Sasso can do a much better job than I can at estimating those, but I just simply interpolated those based on the data points I had that were both above and below the dose of interest. So anyway, they're estimated doses that I used to model the tumor data. Using absorbed target tissue dose, EPA software suggested for male mice, the Probit model, it had a lower AIC than EPA's selected model and fit the data much better visually. And its sublinear shape below the POD is more consistent with what's expected based on the target tissue absorption data. And again, I don't recall any discussion in the draft as to why such a model should not be selected. Using the target tissue absorbed dose estimates for female mice, the EPA software suggested the same model as EPA selected, although by visual inspection, the Hill model fits much better because the data themselves don't appear linear across the dose range. And then I note that importantly, when target tissue absorbed dose is used as a dose metric for female mouse tumors, the model suggested by EPA's software, which again is the same one EPA chose in the draft, has an appreciably lower AIC. So an appreciably lower AIC when target tissue absorbed dose is used as a dose metric. And in fact, using target tissue absorbed dose as the dose metric, most of the BMD models have lower AIC values than the AIC value for the model selected by EPA using the dose metric in the draft assessment. And so this appears to suggest that target tissue absorbed dose is a better dose metric, not only because it's more causally related to excess risk, but consistent with this, it also appears to result in better model fit to the tumor data themselves. And so I suggest, again, that target tissue absorbed dose should be considered by EPA as a dose metric. And also that models that appear sublinear over the lower part of the dose response should be considered for selection by EPA, as they provide a better fit and may also reflect the sublinearity in dose response expected based on the target tissue dose absorption data. And so those are my comments.
So would you say that's a tier 1 comment with the proviso that they should just provide scientific justification for the dosimetric that they use?
Well, I currently call those tier 2 suggestions. I think it's a pretty important, and I think I've provided some good examples as to why these things should be seriously considered. So, but as of right now, in my preliminary comments, I have them down as tier 2.
Okay, I mean, they sound pretty important to me. They sound sort of tier 1-ish, with the proviso that they might have a reason for selecting an alternate dosimetric. I just don't know what it is.
Well, again, they have a table C2 in the draft assessment that cites the uncertainties associated with trying to use a target tissue absorbed dose. But sort of in my mind, the results speak for themselves, that you get better model fit, even in my quick examples that I ran here. And so I certainly don't disagree that these should be considered tier 1.
Okay.
But Mr. Haney, could you say again what table the uncertainties with using absorbed doses so I can look at it later?
Yes, in my comments, I identify it as table C10. Okay. And I normally give the page. I know I just.
That's okay, I can find it.
Okay, yeah, I know I just covered it, but yeah, I normally give the page.
Okay.
Thank you.
Are there other comments? Okay.
Yeah, I agree that these are tier 1 recommendations. And again, the final choices as to what PODs are selected for RFD derivation will be with the agency, but they need to provide these alternative considerations and include them in the appendix, and then justify in comparison of dose metric that is being used.
Yep, sounds good.
All right, thank you. I had some comments, and these are really written up in response to charge question 6, but I think they're relevant here as well. It has to do with the use of the body weight to the 3/4 scaling factor, which is used for interspecies scaling. And it was, as it said in the document, they used that factor because they did not have sufficient information to develop a portal of entry dosimetric adjustment factor for the oral, and I presume for inhalation. And they based this upon the EPA's guidance from 2011 for body scaling factors. And I read that document, there are actually 2 different rationales for using portal of entry scaling. And one is simply based on body surface area, the idea that in humans, we have much larger lungs than in a rodent, and therefore there's a much larger target tissue, more cells to be targeted. So humans will be more susceptible than when the rodent will be. And so that scaling factor is used to make that accommodation. That's the body weight to 3/4. However, there's another rationale for body scaling factor, which is used in that 2011 guidance document, that indicates that that food and water, essentially, consumption is related to metabolic rate, and it also follows a body weight to the 3/4 relationship. So it recommends that body weight to 3/4 power scaling be used for portal of entry effects But in this case, the consumption of the rodents is substantially greater than the human. So on a body weight, body weight basis. So if you look at a mouse will consume something like 14% of its body weight per day, and humans don't consume that much. So in this case, the rodents are getting a much higher dose, and presumably this is inhalation as well as oral because of diet and water. So in essence, you have two scaling factors that are appropriate here, body weight 3/4, but they're in opposite directions. So in essence, it seems to me they may cancel themselves out, and that's something I would ask for more clarification or correction from the EPA on this, because they've chosen one of these to apply, but they didn't choose the other one to apply, and they both seem applicable to me. I hope that was clear.
Are you talking about oral and inhalation, or inhalation for the body weight to 3/4?
Well, actually, this is for,
Right now.
it's for both of them, actually. It's the portal entry dosimetric adjustments.
It really applies to everything because it's for non-cancer and cancer, and I think charge question 6 about cancer, right? You said it might apply to,
Well, I wrote this up for charge question 6, but it probably applies to this as well.
because they used it for reference
Because it's
doses,
being
too.
used
But,
for,
yeah, I had because they used both the model relating to the differences in reduction and combined with body weight to the 3/4, and I was really, for the GI, and I was very confused why they were using both, but I can read, so I found it in, I think, the appendix. It says that this was what its EPA said, because the volume of the small intestine, like other tissues, varies between species by allometry. Interspecies scaling by body weight to the 3/4 is numerically similar to scaling by small intestinal volume. It was hard to find that.
yeah, so this is the surface area comparisons, that there's the scaling. And this happens commonly because
Well,
interspecies scaling generally follows surface area, which is related to oxygen consumption and basic metabolic rates. So that's kind of the rationale for doing it. But it seemed to me, and I wrote this up for charge question 6, but it seems appropriate here as well. That's the reason I
it
brought it up.
does.
And it's just from the EPA to think about this and add a little more clarification, either in the document or correction, is the way I'm thinking
That's
this.
like their standard, it's not just for portal of entry, that's their standard approach for all endpoints, body weight to the 3/4 for systemic effects.
Anyway, but this is specifically for portal of entry description, because in essence, let's say in the intestine, if the animal is consuming far more food than a human, that animal is going to be, the intestine of the animal is going to be exposed to much more of the chemical than the human will be exposed to on a surface area sort of basis.
They already, it's kind of hard, at least for me to think about, but I think they're adjusting for the dose, wouldn't that be, if they eat more, well, this is drinking water studies, so they're adjusting the administered dose by these factors for the chromium.
I believe that's the case. It's the same for the lung. A mouse inhales 10 times more per kilogram body weight than a human. It's the same concept.
Yes, so that would indicate for the portal of entry effects, the mouse or the rat would be exposed to a higher concentration than the human would.
Right.
Right.
But on the flip side, the humans have a much larger surface area, so therefore more target cells. So that was the other, so there's two different issues going on, two different processes that more or less cancel each other out. Both of them scale on body weight to the 3/4 power. One indicates humans are more sensitive, and the other one indicates humans are less sensitive.
For portal.
At least I know in the RFC document, they normalize for ventilation rate and then they normalize for surface area. So it's all considered in the RFC document. I think we're talking about a tier 2 comment here that they need to clarify, if I'm hearing this correctly.
Yeah, I mean, the problem with it is because it directly impacts one of the uncertainty factors that they're using, actually, I would think it's more of a tier 1 comment that really
Okay.
needs to be examined because it has potentially a tenfold influence.
I think that the
Okay.
uncertainty factor for animal to human, if I remember correctly, is reduced to 3, and that's when it's like general practice, when there's a specific, whether it was done right or not, which is your comment, that's a different issue, but when there's like a chemical-specific adjustment for toxicokinetics, like we're talking about, then the 3 is for toxicodynamics, and they don't use an uncertainty factor for toxicokinetics.
Well, it may be, and we could ask to
Maybe
clarify
EPA
this,
can
but
clarify.
this may be only appropriate for the cancer where I think they did it, but I thought it was also relevant to the non-cancer, but maybe I'm incorrect.
I do think it would be relevant to non-cancer as well, as Dr. Post was saying, because it would be part of the toxicokinetic component of the interspecies variability factor. And you're right, I mean, usually for compounds that are metabolized on a body weight basis, using the body weight to 3/4, humans wind up being more susceptible. But when we think about it, where we do it in a more sophisticated way for inhalation, where you consider the dose to the surface of the lungs, you consider whether it's absorbed. Here we're looking at dose to the surface of the intestine. So, you know, it may not be that the body weight to the 3/4 power would really reflect that dose the way if we were looking at it for a metabolized compound.
Actually, as it states in their guidance, it's not a bad approximation. It's just that it says the animals would get higher doses proportionally. And so therefore they would be more susceptible to damage. So it's in opposition. You have two different things going in opposite directions here.
Right.
And that's for the clarification. They can sort it out. It's just, I thought I'd point it out.
Right. Thank you.
So, Dr. Eastman, when you revise your comments, can you like copy that into charge question 4 too, so it can be included in the summary
Yeah,
that I read?
I'll just copy and send this to you, and you can edit it down as you want.
Okay, thank you.
I have a comment and also a question for Dr. Haney. So you've been referring to absorbed dose to use for alternative dose modeling. I think the data that we're using is after 90 or 180 days of exposure, so it's not really absorbed dose, it's retained amount of chromium, because absorption occurs and then there is some excretion. Some portion of chromium is retained, but portion of it is excreted. So alternative interpretation for nonlinear percentage of retention is that at very low dose of chromium, you know, it's more effectively excreted, while at higher doses you have chromium protein binding. And we know for other metals like lead, arsenic, and probably cadmium, there are inclusion bodies at high doses, so that there is accumulation. It's in the inactive form. My question is for clarification. Maybe I understood wrong your comment. You said that for female mice or male mice, there is nonlinear extrapolation at low doses based on retained dose, but for male mice or opposite sex was actually still linear. Is that correct?
It's that the data were collected in the female mice. So actually, I don't have this information for the male mice, because in the mouse study that I use for this analysis, it was the female mice that were dosed only.
Okay, are we all good on this? All right. Thank you, Dr. Post. Let's move on to question 5. Dr. Borsick?
Sure. Just a minute. Got quite ahead of ourselves, didn't we?
Yeah.
All right. So I won't read it. You all can read it here, I think, despite the white on the blue background. Essentially, what we're trying to do here is consider whether or not the various uncertainty factors that were chosen are appropriate. So question A, has uncertainty been adequately accounted for in the derivation of the reference values?
Call from Larry.
Please describe and provide recommendations if needed. So I've we have comments that were sent ahead by myself, by Dr. Post, by Dr. Rusin, by Dr. Haney, Dr. Chen on this first one. Do you want me to share all of them, just the tier 1 or the tier 2?
Let's start with the tier 1.
Yeah, okay. So on this one, the tier 1 suggestion came from Dr. Post. It says that a PBPK model or BW 3/4 scaling should be changed to a PBK model and or BW 3/4 scaling. So that just seemed like changing the or to the and or. Dr. Post, do you want to defend that or explain that?
It's really just a clarification to be consistent with what was done, because I don't remember, I guess for some of the endpoints for the GI endpoints, they used both, and just the way it was written, it sounded like one or the other was used. That's all. It's just a clarification to reflect what was actually done.
Yeah, good. And you had a related tier 2 suggestion there too. Also, it seemed to be a straightforward clarification. Can I have a question maybe for other members here of the committee. As I mentioned when I introduced myself, I'm not as familiar with the details of the particular process here and the choices around the uncertainty factors. But my understanding upon closer reading is that there's a routine use of the uncertainty factor of 3 that felt a little arbitrary. But then when they're multiplied together, they typically are multiplied and rounded up to nearest order of magnitude. So I understand that the 3 is really an approximation for 10 to the 1/2 power.
Correct.
And so I guess, is that standard enough procedure that doesn't need to be explained anywhere?
Yes.
Okay, good. Okay, thank you.
It can't hurt to just write a sentence saying that. We usually do that in our New Jersey documents because some people have the same question that you just had.
Okay.
We usually write that when we use 3, like a footnote or something.
It wouldn't hurt on the first use of it, at least. It took me a little bit to just understand exactly that. So anyway, I have that in my notes, so that'll we'll include that. Let's see, there's no other tier 1 suggestion on question A, although Dr. Chen, you had a few comments that I wasn't quite sure how those translated into a suggestion. I don't know if you want to share those and maybe help me to understand if you had a suggestion there or whether those were just observations.
For the question for 5A, actually.
5A, yeah, you had two sets of comments, and I didn't know how to take those.
Yes, for those comments, actually, I basically think the values are appropriate. I don't really have comments forwarded to revise those.
Good. Okay, that's how I understood it too, but I wanted to make sure I wasn't missing something. Okay. So I don't know if anyone else has anything to add to question A. I think in general, I think we are in agreement with the choices, and there were just some points of clarification.
Mark, this is Ivan Rusin.
Yeah.
So I have edited my comments to say that it's a tier 2 recommendation that I had for the figures to clearly identify which point of departure is a starting point, and then to break that floating bar into sections to clarify which uncertainty factors are actually a composite uncertainty factor to the candidate RFC and RFD. So.
Great. Yeah, I understood that probably as being a tier 2 recommendation, so I guessed as much. Thank you.
I had a quick comment, if I may.
Yeah, of course.
Yeah. So for A, I bring up the low L to no L uncertainty factor since it did not have a section on its own below, and I reiterate a tier 2 suggestion that EPA should reconsider the use of BMD results for diffuse epithelial hyperplasia of the duodenum in female mice, which they had said there's too much uncertainty in estimating the BMD. And I just comment that it may be even more uncertain to simply apply a default low L to no L uncertainty factor of 10 to the low L. It results in a value that's lower than the BMD that is at least informed by the fit of a model that the benchmark dose software actually recommends as a viable model. So again, the tier 2 suggestion is for EPA to reconsider that decision.
When you mentioned you reiterated it relative to when was that suggestion previously made?
It's probably just right above at least in the section on benchmark dose modeling, and I just bring it up here because anyway, it has to do with a related comment on the use of this default low L to no L uncertainty factor of 10.
Right. Okay. So there's in response to a previous charge question.
Yes.
Okay. Thank you.
Okay.
All right. Question B.
Yeah.
They're in front of you. The key here was that they used a Monte Carlo analysis. And so as a result of the Monte Carlo analysis, the uncertainty factor was lowered from 10 to 3. Although the question was, is there maybe residual pharmacokinetic variabilities that the model didn't account for? They're discussed qualitatively. So the question is whether is 3 scientifically justified and clearly described value. Let's see. Dr. Post had a tier 1 suggestion. It's suggested that it be specifically mentioned that the lower 1% value is used in the discussion on pages 414, lines 11 through 12. I think it wasn't quite as clear as it could have been. I guess that the lower 1% value was used.
From what I remember, it was stated elsewhere, but what I was saying is that they were asking if the uncertainty factor of 3 was sufficient.
Right.
Because there may be other residual pharmacokinetic variability for susceptible populations that might not have been considered in the model, the approaches that they used to account for pharmacodynamic dynamic variability. Basically, they used the lower 1% value instead of like a central tendency value, so that makes it even more protective. That's what I was saying. So that further accounts, that's like a further way of addressing uncertainty, and I don't think it was mentioned in that part from what I remember.
I see. Okay, so just highlighting the fact that they were fairly I guess conservative with respect to the choice of the percentile that was used.
Right.
Or precautionary. Okay.
So let me just make sure that I understand. There's no suggestion to change the uncertainty factor. Are you suggesting to actually removing this uncertainty factor because it's already a conservative approach?
No, I was just saying I agreed with it, but they should just for their explanation to just mention that fact, because it wasn't mentioned, it was mentioned in other parts, but not there, to further support that. That's all I was saying.
But perhaps this is a tier 2, it's a clarification rather than a major change, right?
I thought tier 1 was necessary, and when I just make clarification suggestions, I always say they're tier 1 because I'm not suggesting anything be changed in what they do. I'm just saying to add some more information that's already in another part of the document. So tier 1 is supposed to be necessary, not whether it's clarification or to do something different, as I understand it.
Right, so it sounds like that would be a tier 2 comment.
Maybe I misunderstand tier 1. All my clarification comments, or if they're edits, because they're tiny things that just need to be fixed, I always say they're tier 1 because I figure it's not a lot of trouble to just add a sentence or clarify. I'm not suggesting they did something that I disagree with and they consider changing it. So maybe I'm interpreting tier 1 wrong, but I wrote all of them as tier 1 because it's like if I was proofreading it or editing it, I would have made those things in track changes. So because they're easy to do and they just help the reader, I usually call them tier 1. Maybe I'm interpreting what tier 1 is incorrectly.
But from what you're saying, you think that they're easy to incorporate and therefore they should be incorporated.
I'm not saying that I disagree with anything EPA did. I'm just saying you said this somewhere else, and if you mention it here too, it'll help make what you're saying clearer. So why not just mention it there?
So I'm going to read to everyone the tier 1, tier 2, and tier 3, and what the idea behind each of them is. And we have this as part of the charge questions when we originally received them. So again, tier 1 are the necessary revisions, and use this category for any revisions you believe are necessary to adequately support and substantiate the analyses or scientific basis for the assessment conclusions, or to improve the clarity of the presentation in the Chrome 6 toxicological review. Those are tier 1s. Tier 2, suggest. So basically suggested revisions. Use this category for any revisions you encourage EPA to implement to strengthen the analyses or scientific basis for the assessment conclusions, or to improve the clarity of the presentations in the Chrome tox review. Tier 3, these are future considerations, so more long-term issues. Use this category for any advice you have for scientific exploration that might inform future work. While these recommendations are generally outside the immediate scope or needs of the Chrome 6 toxicological review, they could inform future reviews or research efforts. So that's basically it's short-term, medium-term, and long-term kind of recommendations.
Sue, where do you put typos?
Excuse me?
Where would you put typos?
Typos. I think those are necessary.
Tier 1.
This isn't quite a typo, but I think I agree with Dr. Post that this is something that's necessary for.
So I'm just saying to clarify or correct or clarify to just like add a sentence about a point that's already made somewhere else, because it helps support what they're saying in that other
They're minor
part.
but necessary.
Right, and so like say they're tier 1 and they're not like any, it's nothing different. It's just like you said, clarification.
I think Dr. Post has this correct. The definition of tier 1 says to enhance clarity, and you're saying you need to do it. So it's tier 1.
And clarity is in both tier 1 and tier 2, but in tier 1, it's necessary to improve the clarity. In tier 2, it would help improve the clarity. So I think what you're talking, I think it is tier 1 that it really is necessary to improve the clarity.
I agree.
Yep.
I know somewhat more, perhaps requiring a little bit more discussion. Dr. Chen, I didn't label this as tier 1 or tier 2, but nevertheless, I think it's substantive. Dr. Chen mentions the additional variability for the more vulnerable populations needs to be considered. if the overall interspecies variability, including the more vulnerable populations, is still accounted for by uncertainty factor of 3, that context needs to be clearer in the text. Dr. Chen, I wonder if you have more specific recommendations there. I think this is quite what I understand they're saying they're not able to do, and therefore are using the uncertainty factor of 3 in the Monte Carlo simulation. Are you aware of some additional studies or some other way in which this variability for the more vulnerable population should be considered?
No, I think EPA made it clear that they don't use the qualitative words considerations in the for the susceptible population in addition to the PK models using UH3. And
Right.
my point is probably talked about by Dr. Post to sort of to become a little more clear in terms of how you actually consider susceptible population, especially there's a huge variability in the human population especially. So I guess it's more like tier 2 to be to get a little suggestive to be more clearer on that part actually, especially for the more vulnerable populations. It could be life stage, it could be some others.
So it's more like clarity is needed, not necessarily. So I understood maybe that this additional variability in more vulnerable populations need to be considered might be like a tier 3 recommendation for something to consider in the future. But maybe in the context of this report, it's more a matter of clarity that this is how that this uncertainty factor is intended to account for that.
Yeah, if it's tier 3, I'm okay with that. That's fine. Yeah.
Yeah. Okay. It sounds like something that needs to be further studied, but probably not. I don't think they can do any more about it in the context of this report. Okay. So I'll label that as a tier 3. Thank you. That's all. There were a couple of small tier 1 suggestions. Dr. Haney had, tier 2 suggestions regarding the adversity consideration, selecting the Monte Carlo analysis percentile. Any further thoughts on that, Dr. Haney?
No, it's really just a peripherally related issue that has to do with for the justification of a intra-human uncertainty factor of 3, but not about that 3 itself.
Yeah, right. Okay. Anybody else? Anything on part B?
Okay.
Great.
Part C.
And I'll let you read this.
I'm going to go ahead and read it just in case somebody is just simply on a phone line rather
Oh,
than.
sorry. Yeah, thank you. I'd forgotten that was the case. Go ahead.
A database uncertainty factor, UFD, of 3 was applied to the inhalation respiratory effects, both human nasal and animal lower respiratory. A value of less than 10 was applied because respiratory tract effects of inhaled Chrome 6 are considered portal of entry effects and are therefore likely to be amongst the most sensitive based on current understanding of pharmacokinetic and mechanisms following inhalation. A value of UFD equals 3 as opposed to uncertain factor equals 1 was applied because many of the inhalation studies were low confidence, particularly for non-cancer effects outside the portals of entry, and limited in scope, parentheses, working age and mostly male humans, and only male rodents, close parentheses. Due to pharmacokinetic differences from oral exposure, Chrome 6 is detoxified in the gut and liver on first pass. The stronger oral database, UF equals 1 for all effects following oral exposures, could not be used to inform the UF for inhalation effects. Is the rationale scientifically justified and clearly described?
So I think I'm going to start with Dr. Rusin. He mentioned that maybe uncertainty factor 1 would be more appropriate given the strength of the data that are available. Want to discuss that?
Yeah, I strongly support this as a recommendation from the committee because, again, it's absolutely unquestionable what's happening at the portal of entry in both humans and in rodents. It's a portal of entry toxicant, and the fact that there are few studies should not introduce additional divide by factor. As we've heard already, there's quite a bit of there's a gap between where some of the numbers end up in this assessment versus some other agencies. So I think extra conservative factors are not needed in this particular case because we really do understand the effects, and the fact that there are few studies is not a reason to divide by additional uncertainty factor.
This is John. I agree with Dr. Rusin. Right, that nasal effect has got to be the most sensitive effect. It seems quite logical. So I'm not sure we need that additional uncertainty factor of 3.
How does this get expressed as it sounds like it's an important factor, but I don't know if we can require it per se. Is this a tier 1 or tier 2?
I think it's a tier 1 because, again, it will impact the candidate RFC as well. So,
Dr. Haney, you had some discussion on the interactions among the various uncertainty factors. Does that also support this choice here, or would it push it in another direction?
Well, I do tend to agree with what I'm hearing from folks like Dr. Rusin. My comment, says that EPA should reconsider the value, and that whether or not the value changes, that would result in a stronger justification for it. So, I say that they should consider it in a more detailed way in the context of other uncertainty factors that are already being used, recognizing the interrelatedness of uncertainty factors, considering the implications of mechanistic evidence and TK evidence in regard to the potential for more sensitive remote effects, since they cite that as a concern. And and say, for example, it'd be great if PBPK could be used in any way to estimate the approximate inhalation exposures that would be required to achieve the same order of systemic distribution as cause systemic effects through oral exposure, so that could be compared to the inhalation low L's and BMDs available. So I think all these sorts of things can better inform what database uncertainty factor you really need and is more fully justified. So I'm suggesting, essentially some additional work, but at the same time, I do hear comments from the other reviewers that just commented that a great deal is known about this, and just from that may justify a lower database uncertainty factor.
Yep. Dr. Chen, you supported the choice of 3. How do you feel about the recommendation of 1?
Yeah, I support the uncertainty factor for 3. And I think I hear what Dr. Rusin talking about to using 1. The only clarification I want to see is this. Certainly, EPA said it's using the males and certainly workers, male workers, and male rodents. And for females, do we need to consider anything? But I'm definitely okay if we want to decide. Actually, finally, we'll go to 1 as the recommendation. Just want to get that part.
Thank you. So it sounds like the those who reviewed addressed this charge question agree with one, and I also can agree with that based on what I'd heard over the last couple of days. Are there others that want to weigh in on this? Again, just to be clear, is this the type of recommendation that we can make as a tier one, that it's not just for their consideration, but we actually see it as a necessary one? I mean, I certainly agree with the importance of it. Does that mean we can require it, so to speak?
I mean, that's how the question was phrased. You know, do you agree with the choice? And the answer is we don't, and we make a different recommendation. So
good. Okay. Thank you.
I'm not seeing any other questions or commenters asking to speak here or online, so I think we're finished with.
Can I ask so I didn't focus on that uncertainty factor because I wasn't assigned to that, but we'll have the opportunity. I'd like to read what in the documents, what EPA had said about it and decide if I agree or not. I'm not saying, so we'll have a chance later when we discuss the draft report and stuff, if we read more about it and agree or disagree, right? Correct, Sue? Sure. Because I don't know anything what to say right now. Thanks.
Yeah.
You want me to? I'll make a note to connect back with you on that. Does that make sense?
We'll all get to see the final document,
Okay.
the draft of it. So we'll all have the opportunity to chime in on anything.
Great. All right. So make a note yourself then.
Yeah.
And you have an opportunity to revise your preliminary comments. So if you find that you want to add something to a question that you didn't previously respond to, you are
Okay, thanks. That's good too.
Dr. Zitkovich?
I actually do not understand the argument why it should be 1, not 3, because 3 I thought was is to account for uncertainty that the worker population may be not represented, might not include the most sensitive populations, because we know there is a healthy worker effect. So 3 seems to be a reasonable uncertainty factor. It's not a 10.
yeah, so this is a different component. The intra-human variability is a different uncertainty factor. This one is for database, how many studies we really have to evaluate our confidence that this health effect is actually occurring. And in this particular case, it's a portal of entry toxicant. There's a considerable amount of evidence of its effects. So the fact that only 3 or a small number of studies have looked into this particular lesion occurring should not detract from the fact that we have great confidence that it does occur. So it's really the database uncertainty factor is for how many studies you have, is not to account for intra-individual variability. There's a different uncertainty factor for that.
Dr. Eastman?
Just for clarification, it seems to me that it's not the uncertainty that this effect occurs. It's the uncertainty this effect occurs at that concentration. And that's where the uncertainty is are we confident that's the concentration at which this effect occurs? And that's why they recommended a 3-fold uncertainty, because they're pretty sure but not fully sure. So that's how I interpret this.
It's saying that, I don't remember the details of which studies there are on this, but in general, that other studies, maybe in other populations or whatever, might show a more sensitive effect that what could be 3-fold lower.
Well, I think actually what they're saying is, just in the charge question, I mean, unless there are a lot of issues up here, I think we have really strong data on the dose response for the nasal effects. I don't think there's a lot of uncertainty in that. What they're saying is there's uncertainty in whether they're non-cancer effects outside the portal of entry by inhalation in humans. I mean, that's what they say the concern is. But I think Mr. Haney's got this right. I mean, you go through pretty straightforward, kinetics. The absorbed dose is going to be so low, I don't think that's at all likely based on the information that we know.
Dr. Zitkovich?
Sorry, I'm still confused, even though Dr. Rusin seems to give a very clear answer. So that refers to database uncertainty. So we discussed yesterday that they're using database from Gibbs study, but in fact studies among chrome platers found to be more sensitive, this outcome to be more sensitive to chromium exposure. So it seems to me there is some uncertainty in database. They rely on Gibbs, but there are studies from chrome platers actually give lower dose effect if compared to pure chromium Gibbs studies. So isn't that uncertainty though?
I think that actually the issue with those other electroplating studies was that was actually to chromic acid. And that chromic acid is not likely predictive of the environmental exposures because of the acid effect. And what we really asked them to do is to more clearly specify why they picked the Gib in light of that concept.
I'm wondering if EPA would like to provide further clarification of the choice of the uncertainty factor here, 3.
Hi, so you're talking about the database uncertainty factor.
Database uncertainty
I mean, it says in the question, I mean, we're talking about what we possibly don't know. I mean, again, outside of the portal of entries, but I mean, if everyone agrees that we're 100% certain, are we 100% certain that the nasal effect is the most absolute sensitive effect? And that's kind of the question is, what Mr. Haney said, is there, it's possible that there's not enough of an absorbed dose from inhalation to cause any of those other systemic effects. So, it's where, it kind of straddles multiple uncertainty factors in a sense. Like that's why, we kind of end up pulling in, discussions about the intra-individual variability uncertainty factor. But, that's the main question is, do we believe that the nasal effect is the most sensitive? And we thought that there was maybe some residual uncertainty, when it comes to the systemic effects, because of the fact that there's just very low quality studies in humans on, outside the nasal cavity. So the database is really focusing on the number of studies that and the number of endpoints. So we hedged on 3 because we weren't really sure because of the fact that the inhalation databases for non-cancer effects is somewhat weak.
So again, toxicologically, we do appreciate that most reactive compounds like chromium-6 and others will exert portal of entry effects. And these are at the site of first contact. So again, in my opinion, and that's the argument I made, there's no reason to compound uncertainty factors just on top one of the other. I think this is the one opportunity for the agency to really, believe and not to be super conservative or unnecessarily conservative.
I think Mr. Haney has his hand raised.
Oh, right. Yeah.
Yeah, just what Dr. Rusin said about compounding uncertainty or compounding these factors. In my comment, I talked about one consideration should be the interrelatedness of uncertainty factors. And, at least in my mind, the subchronic to chronic uncertainty factor, the UFS of 3, is an example of this, because there we're using a 3 because we're using a subchronic study. Well, that's just another way of getting at database uncertainty. Had we had a chronic study, then we wouldn't have to use this. So, in my mind, a UFS of 3 for having to use a subchronic study, that is related to the database uncertainty factor. So let me just point out that we are using a 3 there for having to use a subchronic study.
Are there other comments? Although, Mr. Haney, I have a question, and I didn't look at this in your comments, but are you recommending that the subchronic to chronic uncertainty factor is not necessary? I mean, it seems as though if you're looking at I guess you're looking at inhalation in both cases, but it seems as though it is somewhat qualitatively different from the question of whether have you missed a particular endpoint, which I think is what the uncertainty factor for database here was being used for.
Right. No, my comments don't suggest that the subchronic uncertainty factor B1 is just as part of my my comments on the database uncertainty factor do suggest that EPA reconsider the database uncertainty factor of 3. They fall short of saying it should be 1, but it seemed to me that they could consider that they could reconsider it and do a more detailed analysis of what that value needs to be, and just part of that was considering the interrelatedness of all the uncertainty factors in addition to other considerations like TK and any ability to use route-to-route extrapolations to get an idea of what type of inhalation exposures would be needed to achieve the same sort of systemic doses that cause effects through oral exposure. So I was suggesting more work to get a handle on these sorts of things, and that would better support the database uncertainty factor regardless of what value was ultimately selected. But at the same time, I hear these comments by others that there can be great confidence in us knowing what the critical effect is, where it occurs, and things like that. So I'm not sitting here today. I'm not opposed to the idea that it should be 1.
Thank you. I just did want to note that the uncertainty factors really are not totally independent in a way. And for example, if you have 4 uncertainty factors, and even if each of them is 10, typically the agency would not have a composite uncertainty factor of 10 to the 4, but of 3,000 because of the concern of compounding uncertainty upon uncertainty. So they're not, it often can be a complicated analysis and interpretation.
I mean, there's always some residual uncertainty in this business. We know nothing with absolute certainty. The sense is that we don't need to add an additional factor of 3 given the toxicological response at the target organ, at the route of entry. And you could just do a simple calculation of total inhaled dose versus total ingested dose, you know, to try to compare that. It's just not at all likely that there are going to be distant effects in distant tissues. I mean, that's where we're coming from, I think, on this. And so we just don't need this uncertainty factor of 3, considering all the other uncertainty factors that are incorporated. Am I having the last word on this?
It sounds like it.
Sounds
Yes.
like it.
Yes.
Okay, let's move on before anyone can disagree.
This next one may be a little bit more straightforward. Of the comments I received from the reviewers, one is kind of substantive as a recommendation, as a tier 2 suggestion from Dr. Haney about considering just further strengthening the justification, I guess, for not using 1. Sounds like you feel like the information is there. It could just be put in context a little bit more, or is there additional information that could be brought to bear, Dr. Haney?
Yeah, this is just based on my interpretation of what's said. A rationale has been provided for a subchronic UF of 3, although I think perhaps it could be better clarified. I mean, that'll be up to EPA. The first reason that EPA cites is that it's less likely that exposure to Chromium-6 outside of occupational settings would induce nasal perforations and ulcerations at much lower concentrations and particle sizes. The thing that was really triggered my comment was the second reason that was cited. It seemed to me that the premise of the second reason cited, which was the reason for not using a value of 1, seems to be that Chromium-6 induced nasal lesions will occur in the environmentally exposed population in the first place, and then may become more severe if a value of 3 is not used. That is, it seems to me that the reason they cite the intent of using 3 seems to be reducing the severity of nasal lesions induced by Chromium-6 environmentally instead of protecting against them in the first place. So as a tier 2 suggestion, I thought maybe EPA should consider strengthening that justification. And sort of the type of text that came to my mind at the time is a sentence something like, however, a value of 3 is retained as there is residual uncertainty regarding the possibility that somewhat lower long-term environmental Chromium-6 exposure could induce adverse nasal effects or exacerbate pre-existing nasal conditions in susceptible population. And then I gave an example there. So anyway, at least in my mind, as I sat there and wrote this comment, I thought that was a better justification for keeping the 3 than what was provided in the document.
Yeah, thank you. That makes a lot of sense.
Are we hearing anything else?
I'm not seeing anyone here commenting or on the screen.
Okay.
Thank you.
Have we done it? I think we did it.
Yes.
Okay. So we're done with 5. And then we're have good old question 6 ahead of us. Rather than start with 6 right now, why don't we do lunch right now? And then we can do the afternoon for question 6. And we may have some things we want to talk about tomorrow. So don't everyone race to the airport at 5 o'clock tonight. The 4 of us on the videos won't be racing to the airport anyway, I suppose. So let's do that. We'll get ready for the big discussion this afternoon. An hour and 15 minutes would mean that we will reconvene at 1 o'clock.
Okay, we're recessed until 1 o'clock this afternoon.
I just want to comment that, Chrome 6 contamination of ground. Rationale has been population. And
Dr. Morris?
Yep, I'm here.
Oh, you can go ahead. We've,
Okay, welcome back, everyone. So we've made it to question 6, and I believe it's Dr. Eastman who's going to lead this part.
Okay, thank you. I'll give a little bit of an introduction. That charge question 6 involves a series of questions regarding EPA's decision that chromium-6 acts through a mutagenic mode of action, that an age-dependent adjustment factor should be applied, and that linear extrapolation should be used to estimate low-dose risks from both oral and inhalation exposure. The reviewers for charge question 6 were prolific, submitting 76 single-space pages of initial responses. I've tried to summarize them to begin our discussion, but undoubtedly I will miss some important points, and the individual members will need to correct or supplement what I say, I'm sure. There were 4 subcommittee members asked specifically to respond to the charge question. 2 others also provided responses. All of these have been combined in this summary. And although not specifically asked in the charge question, it appeared to me that all that responded seemed to agree that chromium-6 can cause lung cancer in humans, cancer of the oral cavity in rats, and cancer of the small intestine in mice. So that's a big step in many risk assessments. We're past the initial debate over, is there an effect or not? So in response to charge question 6 regarding EPA's conclusion that chromium-6 acts through a mutagenic mode of action and the use of linear extrapolation, the reviewers expressed a range of opinions. And the way I've written this up was, I've pretty well gone through A, B, C, and D because they're interrelated, but we can split them up or go back to them if we want to at a different time. But let me start right now. So 4 of the group felt that the evidence that chromium-6 causes cancer through a mutagenic mode of action was sufficiently supported and relevant to humans. One reviewer wrote that there was a lot of additional genotoxicity and mutagenicity information, particularly from standard in vitro systems and in many model organisms, other than laboratory rodents, that should be added to the IRIS document, which would substantially strengthen the case for the mutagenic mode of action. Another noted that multiple modes of action could be occurring at the same time. As a result, 3 of the members felt that linear extrapolation into the low-dose region was the most appropriate approach to model chromium-6's low-dose risks. They also felt that application of an age-dependent adjustment factor was appropriate. The 3 agreed that the point of departure chosen by the EPA was appropriate and agreed with the oral slope factor selected. Similarly, 2 of the reviewers agreed with the approach used to derive the inhalation unit risk, while 1 of them did not review it. In summary, this group of reviewers strongly supported the approaches taken by the EPA in assessing chromium-6 risks. Now I'll focus on some of the others. One of the reviewers expressed the opinion that while there is sufficient evidence that chromium-6 acts through mutagenic mode of action at high doses, additional evaluation of the mode of action data focusing on expected responses in the very low dose region should be undertaken before a decision on low dose extrapolation is made. And therefore, also an ADF, age-dependent adjustment factor, would be applied. Essentially, the reviewer felt that the EPA skipped an important step, which was to use knowledge of the mode of action information to evaluate likely risks at very low doses. In his opinion, the cancer responses in the very low dose region likely exhibit or could easily exhibit sublinear threshold responses, as there are multiple efficient detoxification processes involved that would likely substantially reduce uptake and activation at very low doses. So these are primarily, we're looking at sort of toxicokinetic and maybe some toxodynamic things. Several mechanisms were identified, and this is slightly modified from some that the people saw that I wrote earlier. 1, diffusion within the extracellular space across the mucus layer should be much slower at very low doses because it'll be on a concentration gradient. Extracellular reduction of chromium-6 into chromium-3 prior to uptake by the cell, a process that should be highly efficient at very low doses, should also be efficient at very low doses. The third one is competitive inhibition of chromium-6 uptake into the cell by sulfate and phosphate anions found at much higher concentrations in the extracellular fluid. And 4, efficient intracellular reduction from chromium-6 to chromium-3, which is considered an activation step, but also has components of a detoxification step for secondary sorts of species, should be efficient at very low doses. Let's see. The challenge that happens is that the product of the reduction of chromium-6 to ultimately is chromium-3, which is considered widely as an essential nutrient or considered a beneficial supplement. I know there's some debate about that, but that's sort of the National Academy still has it as an essential nutrient category, and it's in the vitamin pills that some of us take every day. So this form of chromium-3 is commonly accepted to be much less toxic than chromium-6, and again, as I said, either an essential nutrient or potentially a beneficial supplement. So all 4 processes indicated to this reviewer that additional evaluation of the risks at very low doses of chromium should be re-examined before a decision on low-dose extrapolation is made. This reviewer also thought that the rationale for using the body weight to the 3/4 scaling factor needed additional examination. I mentioned that earlier. He was also concerned about the impact of smoking on the study that was used to estimate the inhalation risks of chromium-6. And we'll probably talk briefly about that a little bit later. So another reviewer wrote that EPA has demonstrated genotoxicity hazard, but has not conducted a mode of action analysis that demonstrates a mutagenic mode of action for carcinogenicity. Moreover, EPA's mode of action conclusion is far from representing scientific consensus, i.e. settled science, as scientists at other notable agencies and elsewhere have concluded that an alternative mode of action is best supported by the weight of available relevant scientific evidence. So this reviewer indicated the evidence for both routes, but particularly for the oral routes, was insufficient to conclude that chromium-6 induces cancer through the mutagenic mode of action. This reviewer presented the conclusions of regulatory authorities from Canada, Japan, Texas, and the World Health Organization that the evidence more strongly supported the cytotoxicity regenerative hyperplasia mode of action for the oral tumors, and that as a result, a nonlinear threshold type approach should be used for low-dose extrapolation. The member wrote that the target tissue absorbed dose as the dose metric determined of excess risk is dose-dependent and nonlinear with oral dose, and that dose-dependent nonlinear target tissue absorption for chromium-6 is inconsistent with a linear low-dose extrapolation conducted by the EPA. As a result, this reviewer did not support the derivation of an oral slope factor or an inhalation unit risk. And lastly, another reviewer made brief comments recommending that the EPA conduct parallel evaluation of the 2 primary hypothesized modes of action, a mutagenic mode of action and a cytotoxicity regenerative hyperplasia mode of action, using the International Program for Chemical Safety mode of action framework, as well as an AOP, adverse outcome pathway considerations. So I guess to summarize, I mentioned there's a range of opinion, and you've got sort of those strongly support mutagenic mode of action, linear extrapolation, others that don't support that approach or support that in addition to looking at the sort of cytotoxicity regenerative hyperplasia. And the other one says supports the mutagenic mode of action, but doesn't think it's operable at the very low doses in which we're extrapolating towards. So and just to follow up one other comment, which came in public comments yesterday, that really the key question is produced in the EPA Cancer Risk Assessment Guidelines, and I'll excerpt a couple of them. it really has to do with what we consider sufficient evidence to support a nonlinear mode of action for the general population and or subpopulations. And so that's, if you think if there's adequate data to provide on the mode of action to provide sufficient evidence, then you can go a different route. And another one I found in the 2005 risk assessment guidelines, it says, depending on the strength of the suggestion of mutagenicity, the assessment may justify a conclusion that mutagenicity is not operative at low doses and focus on a nonlinear approach, or alternatively, the assessment may use both linear and nonlinear approaches. So it essentially supports a variety of approaches, but the default approach when a mutagenic mode of action has been shown is to go to a linear low-dose extrapolation. That's kind of the EPA's standard approach, and that's what was done in the document. So all the other committee members can correct me or add to it if you would like. Thanks. Well, looks like
It was a good summary.
Okay.
It was a really good summary, but the way the comment was presented, I mean, not the comment, the charge question was presented had like different parts, A, B, C, D, E, and I think you were synthesizing everything kind of, but are we going to, the way like at least I responded was to each part. Are we going to go through each part and when we discuss our comments further?
if you'd like to, I mean,
I
that's,
don't know,
I think,
it's
what
up
we
to,
would do.
not up to me, but
Well, I think that's the way we ought to proceed, because essentially I tried to summarize, again, 76 single space pages of comments. So that was a condensed version. But I think we will go through individually and just see if people have other comments, would like to weigh in. And it's not just simply this subgroup, but the entire group, because this is a very important decision that the committee will make. So I can jump over to charge question. It may be a little, let's go through this.
I have it.
Oh, I have it right here too.
Yeah.
So let
I
me
think
read it.
that makes sense. Let's do it by A, B, C, D.
Sure.
And let's remember that we're going to try to get to consensus if we can.
Okay.
Maybe we won't.
Yeah. So let me read the charge question, which is posted up there, but for those that may be listening by phone. For each cancer-related health effect decision outlined below, please comment on whether the available data have been clearly and appropriately synthesized to describe the strengths and limitations and to support the conclusions presented. For each, please also comment on whether the weight of evidence decisions for hazard identification have been clearly described and scientifically justified. In addition, please separately comment on whether the dose response decisions are transparent and scientifically justified, including study selection for dose response analyses, point of departure estimates, including modeling choices and assumptions, and dosimetric adjustments, derivative of candidate values, and confidence in the calculated values. So although we were supposed to comment on all of those points on every sub-point, a bunch of them were not really relevant, or I found them hard to make relevant. So here's point A, and this one we'll be talking about initially. EPA concluded that a mutagenic mode of action for chromium-6 carcinogenicity is sufficiently supported in laboratory animals and relevant to humans. The determination applies to both oral and inhalation exposures. For inhalation, there was consistent evidence from humans exposed occupationally. For the oral rate of exposure, the small evidence base of low confidence animal mutagenicity studies of drinking water exposures was supported by strong evidence of mutagenicity of chromium-6 in test systems using more direct exposure methods. For example, IP injection in vitro. And a biologically plausible pharmacokinetic mechanism for chromium-6 distributing to tumor target tissues and being taken up and reduced intracellularly to reduce toxic and genotoxic effects. That's the first one. And I might mention in visiting with some of the EPA staff that that model is pretty involved. So if you're interested in more details, we could ask them to elaborate a little more on it. Anyway, so let me open it up now to those who would like to make comments about this first part on the mutagenic mode of action and its relevance to both oral and inhalation data, and whether people believe it's operable both at high dose and low dose, et cetera. Anyway, that's the first part of this. And I'll call on whoever's, if you're interested, raise your hand, flip up your card, or whatever. Dr. Wise.
I'll just get the conversation started. I did want to comment on the oral animal studies, because we heard a lot of public comment about them that kind of exaggerated the data a certain amount. For example, we were told, there was comments made that chromium is not in the crypts. If you study the papers a little more carefully, that's not actually the case. In the first, let me say it this way, these studies, when I say first, second, third study, that's not the way they were published. But so in the first study, which was a 7-day exposure, there were low levels of chromium in the villus and not detectable levels in the crypt. But the detection limit by this technique is actually fairly high. It's not as low as ICP-MS would be, for example. So it's somewhere around 0.15 part per million or 0.75 part per million is the detection limit. So that doesn't mean there's no chromium. It means it's somewhere between 0 and that number. But when you look at the next study, which was a 90-day study, they actually do detect chromium in the crypt above control levels. It's not high. The villus is higher, but the villus started out low at 7 days and got higher at 90 days. And if you accept that chromium is below non-detect at 7 days, by 90 days it has creeped up to detectable levels. The other thing that's notable about these measurements is it's only one mouse. They did 2 mice, but they only show the data from 1, but they say the second mouse is similar. But there's a great deal of variability in chromium uptake in animals. And so what does it mean? But when I looked at the 90-day data, which shows in the crypts, it's elevated over control, it's on a log scale, and you kind of have to infer, so it could be somewhere from 2 to 5 or 8 times higher than control levels. So there is chromium in the crypt. It's not quite correct to say that there's none. Then when I looked at the gamma H2AX assay, which they did, which we were also told there was no gamma H2AX, when I look at the 7-day exposure, they show, first off, the assay is done in an insensitive way using DAB staining as opposed to immunofluorescent staining. When they did the 7-day, they don't actually report a quantitation of the data. They just show a picture showing that there's some brown staining. But when they do the 90-day, these are scored on a scale of 0 to 3. 0 being no staining, 3 being abundant, 2 being moderate. In the villus and in the tip of the villus, the controls are scored all as 0s. But in the crypts, the controls are all 2s. And so when they score the chromium treated, they're also all 2s. And I think it really reflects the insensitivity of the assay. So I can't conclude that there's no double strand breaks there. I can only conclude I'm comfortable with what they were saying about the tip of the villus there being breaks, but I think that it's uninformative when you look at the crypts. And then I looked at the micronucleus assay, which is actually in 3 different papers. And one of the things that we were told was that the EPA was incorrect, that they actually did use a positive control. And that's true and that's not true. So in the 7-day exposure, they did use 2 positive controls, one of which was positive, one of which was negative. But in the 90-day study, they did not use a positive control. In fact, the 7-day study, which was written after the 90-day study, they actually state in their discussion that the 90-day study had no positive control. In the 90-day study, they're all zeros. The other thing that struck me about it was it's not a traditional micronucleus assay. They simply looked at sections and counted whether micronuclei are present. So I think the EPA's comment that the assay is not standardized and adds to uncertainty is very accurate and very appropriately said, because we don't know if you're just looking for micronuclei without, for example, in cell culture, you would add cytokeratin B to arrest the cells and do any of that. So how many slides do you have to score to see micronuclei? The numbers are very, very low. So I think there's a lot of uncertainty, and I end up looking at the oral studies going, I simply don't know if there's genotoxicity or not. I can't conclude that the oral studies say no genotoxicity. Chromium's getting in there. Maybe there's genotoxicities, maybe there's not. I would prefer to have seen gamma H2X done by immunofluorescence and scoring the individual foci, which is a much more sensitive way to do it. I think they probably did what you could do to do the micronucleus assay. I'm not sure there's another way to do it, but it's important as we think about genotoxicity assays and the micronucleus assay being a standard genotoxicity assay. This is not a standard micronucleus assay. It's just, and that's probably why there was no positive control in the 90-day study being done first. It's a new assay. There's really nothing that's a positive control.
I do believe they mentioned these were done through contract research organizations that do the standard sort of micronucleus test on a regular basis. But as you point out, doing it in these other tissue types is pretty specialized and not, you may not, a lot of these key questions haven't been.
Right, so I end up in the same boat as the EPA. I don't have good animal studies on which to base it, and there's a huge amount of in vitro data that says it's a mutagenic mode of action. The other comment I want to make, I don't know how important this is, but I do want to comment on the essentiality of chromium-3, because it really is no longer considered to be essential. I mean, in Europe, they've already adjusted their guidelines. The work was redone by John Vincent in Alabama, and supposedly the US is in the process of redoing their guidelines that it's not essential. But
I realize that. And there's a whole question about whether, it is used in livestock feed with some, it's an interesting thing because you have some evidence, but it's not convincing and all the rest.
Dr. Sitkovich?
Yes, so I'm a member of this panel for question 6, not a random speaker. So there was mutagenic mode of action. We don't have to define that this is a predominant mechanism. The only thing we need to define whether it's operational. So if we look at chromium-6, it's a pro-carcinogen. It needs to be activated to chromium-3 to cause DNA damage. Now, I made a comment about in vitro assays. So there are some standard assays with very well defined predictive power to say whether it's carcinogen or not. EMS assay, it's a bacterial assay. You can do mammalian mutagenicity assay. You can do mammalian chromosome aberration assay. Each has its predictive power. If you combine them, just in vitro assay, and you don't even know anything about chromium carcinogenicity, you can say, this chemical, more than 90% probability is carcinogen simply based on in vitro tests, which are well validated. And if it was a drug, FDA is not going to approve it because it's positive in all those standard in vitro tests. Now, all in vitro tests. So then the argument is, what is, if it's in vivo, different? So we have in vivo data, not through ingestion, but where you give a sufficiently high dose, IP. positive data for mutagenicity, positive data for chromium-specific damage, such as chromium DNA adders, DNA protein crosslinks, mutagenicity, different tissues. In intrabronchial installation, positive data for mutagenicity, positive data for some oxidative damage for DNA protein crosslinks. So there is plenty of evidence that it's not in vitro phenomenon, that it's in vivo can be induced. There are also data which were not included in this section, but for fetal genotoxicity of chromium. It's genotoxic to fetus if it's given through IP injection. So chromium-6 is genotoxic in bacteria tested, yeast, plants, Drosophila. Dr. Weiss studied in whale cells and all other exotic animals. In all of them, there were no exception. So there is no reason to think that in the small intestine, it's not going to be genotoxic. We can actually take chromium and its activation, it's a pure chemical reaction, either with ascorbic acid or with glutathione. And we can damage DNA, analyze this damage, it's mutagenic. So nobody presented any argument that in the small intestine, its metabolism will be different. Ascorbic acid is still there, glutathione is there. Everything what's needed to activate chromium-6 to chromium-3 to cause damage is there. So I don't see any argument to exclude mutagenic mode of action. I agree that the positive data through drinking water exposure for small intestine questionable, but if you look at the bulk of evidence, it's everywhere genotoxic, mutagenic. And in vitro, if you take colon cell, for example, it's not small intestine, large intestine, but it's still positive. So, and then there is, I'm going to pose a bigger question if somebody proposes alternative. Cancer is a genetic disease. You need mutations. So if somebody argue, we tested exposure, long-term exposure to chromium, didn't find any elevated frequency of mutations in the small intestine, therefore non-mutagenic mode operates. Well, some mutagenic mode has to operate because it causes genetic disease cancer. So if chromium is not directly mutagenic and other mechanism operates, it still needs to produce mutations. So that would be an argument that assay is actually not sensitive because it doesn't detect any mutations. Some of our team leader presented overview of all different components of questions A, B, C, and D. I just want to focus on part A, and I'm going to make comment about the things which more complicated with respect to dose response and uptake. But with respect to mutagenicity, somebody needs to argue if it's saying it's not mutagenic mode of action in small intestine, what is so unusual about small intestine cells that it's totally different from anything else in living organisms, from bacteria to all mammalian human cells, it's small intestine, it's not.
Can I ask a follow-up question briefly? So you talked about the bioactivation to chromium-3 being the thing. As you know, the NTP did a study on chromium picolinate, did their cancer bioassay,
right,
which is a form of chromium-3, and it doses up to 50,000 parts per million in the diet. It did not give positive results for cancer in any tissue. So that's why I have kind of a difficult time resolving. Admittedly, chromium-3 is poorly absorbed, but picolinate form is a little more absorbed. It may be 1 or 2%, but you still have high enough concentrations that should be getting into these cells over a lifetime. Why do you see the difference?
That's because I see a more complete picture. So we cannot consider metal as just some naked molecule or atom floating in solution. It's always bound to something. I'm going to give you an example. You isolate iron-dependent enzyme. If you add EDTA, you're not going to get any iron-dependent activity because iron will be chelated by EDTA, and this complex is inactive. So chromium picolinate is a chelated form of chromium-3. So we can't really consider compare chelated form of chromium-3 versus chromium-3, which is freshly formed. And it actually has 6 bonds it can form. So it grabs a lot of stuff. So No, chromium picolinate, not a good example. It's a good example to say that once chromium 3 bound to something, it's going to be unreactive to other things. But once it's newly formed, it's very reactive. You can reproduce the system in vitro.
Oh, Dr. Russo.
Dr. Russo.
Yeah, an additional argument, I think, is very well described in the IRIS document as to the cell permeability differences between chromium-6 and chromium-3, and the conformation of the molecule and how easily chromium-6 actually can get in and then react with ascorbate and release chromium-3. So this is already explained, just to follow up on your earlier question. But you know, the bigger point here is, again, not to say that it's mutagenic only or it's cytotoxic regenerative proliferation only, or as the draft in the integration of evidence for GI effects in section 3.224 kind of, you know, brings in the oxidative stress, brings in the chronic inflammation. There is a compendium of mechanisms that are operating, and separating them out is very difficult and challenging. So here the argument is that it's cytotoxicity, compensatory proliferation only, and at the same time that there's something special about duodenum or the crypts that makes it not mutagenic in that tissue alone. So as Dr. Wise pointed out, the evidence that is available from some of the recent publications is on gamma H2AX. Another line of evidence that Thompson and all published is in a big blue rat, where they looked at mutation frequencies in duodenum and detected none. Again, EPA considered this study as well and explained, in my opinion, very eloquently as to what are the challenges with that, because mutations are not the only type of genotoxic damage that are important. And what we know about chromium's mechanisms is it's the crosslinks rather than direct DNA adducts that are very, very important. And model systems like Big Blue, mouse, or rat are designed to detect mutations. They're essentially an in vivo version of the Ames test. And what at least I teach is that there are simple forms of damage which are adducts that then result in mutations, and there are then complex forms of damage. There's clustogenicity and, you know, and crosslinks and chromosomal aberrations, and those are not the same. And lack of mutation does not mean that there are not other types of damage. And because we know that in other model systems, chromium does cause very complex adducts, such as crosslinks, and those crosslinks are the ones that will more likely lead to higher type, higher level of genotoxicity, not mutations. You know, the fact that in Big Blue rat, through oral exposure, there was little evidence of increased mutagenicity does not make me believe that mutagenic mode of action is not operational here, because, you know, every model system has sensitivity, and, you know, if Big Blue would have been such a wonder model, NTP and others would have used that rather than 2-year cancer bioassay. But we've been 20 years ago through P53 and ATC and other, you know, rapid models, and they unfortunately missed some big known human carcinogens. So we still rely on a 2-year cancer bioassay as the gold standard, for better or worse, but we have not found a model that is actually as comprehensive in giving us the ultimate end result as opposed to just mutations. So I think the studies by Tox Strategies are very elegant. I think they definitely show that compensatory proliferation is occurring, and where I am is that these mechanisms are complex and they are operating together, and that actually makes it worse, because you do have genotoxicity and you do have compensatory proliferation and you do have oxidative stress and you do have inflammation, and it's essentially a perfect storm to lead a couple of cells into cancer transformation. And I think many of us believe in the single cell origin of cancer. So it is very challenging to prove that mutagenicity would not exist if we know that it's a highly genotoxic compound, as Dr. Zhitkovich and Dr. Wise already pointed out, in all other systems. And I think the only argument would be the chromium is not there, but Dr. Wise just pointed out that that evidence is also, I think, at least debatable. We're not going to come on one side or the other. And all of these things together not only lead me to believe that mutagenicity is operational, whether it's the mechanism, the only mechanism, obviously it's not, but for me to conclude that it doesn't operate in this particular case, in this particular exposure, in this particular tissue, would not be acceptable to me. Now, the second question is on the low dose, and that's something that we'll discuss later.
Very quick, a couple details on what Dr. Rustin said about this transgene system. Most of them incorporated into heterochromatin, and most of those genes are small. So if it's a small gene, that means it's a small target. It's more difficult to detect compared to endogenous genes, and they're not designed to tolerate large deletions. And one of the unique things about chromium, so it induces double-strand breaks, but they all sit in euchromatin. They're not in heterochromatin. So essentially, the target you're using for transgene are located in a different chromatin compartment, which is not being targeted by double-strand break produced by chromium.
Point of clarification, I believe while the target is small, there are like 30 copies. It's still very small and doesn't pick up deletions like you said, but there's multiple copies of the target gene in these transgenic animals.
But these type of models, really, they are not to prove a negative, but they're to quickly prove a positive and to fail a compound. So their use is very one-sided. The six months, cancer bioassay is for you to save money, not entering the 2-year cancer bioassay, to fail drugs early, rather than to prove that environmental compound is safe.
Am I hearing, seems to me I'm only hearing support for the concept that a mutagenic mode of action is occurring. Mr. Haney?
Yeah, I'm sorry. Who was it that began speaking?
It was me, John, but go ahead.
Oh, okay. I'm sorry. I thought someone else was chiming in. Yeah, since I'm apparently seems the odd man out here, so to speak. Anyway, I need to go through what my concerns are. As people saw from my comments were long and pretty extensive, and I almost feel like I need to apologize for that. But these things have to be aired. So I would appreciate your patience as I go through my comments. And I'm just trying to recall the public comment from yesterday, which cited the actual EPA guidance, a part of it, where it seemed to indicate that the standard was not whether or not we can exclude with 100% certainty the possibility that some genotox may be occurring. That really the question seemed to more is what's driving the tumor genesis here in these target tissues. Not that EPA would have to 100% exclude the possibility that some genotox induced by Chrome-6 could be occurring. So anyway, I think that public comment has some relevance here. For above Part A, there's questions about whether things are accurately presented and synthesized, and I did have some comments on that, and those I have several of those, but we're on A, so I'd appreciate if y'all can be patient with me as I go through my extensive comments on this section. And so EPA concluded there was a mutagenic MOA that applied to both oral and inhalation. And so my comments were more geared to whether that decision was scientifically justified, as opposed to pointing out concerns with genotox studies that are cited to support an alternative MOA. So like Dr. Morris said, one of my comments is that EPA has demonstrated genotoxicity hazard, but has not conducted an MOA analysis that demonstrates a mutagenic MOA for carcinogenicity. Moreover, EPA's MOA conclusion is far from representing scientific consensus, as scientists from other agencies and elsewhere have concluded that an alternate MOA is best supported by the weight of evidence. The primary focus of EPA is simply on demonstrating genotoxicity hazard. That is, EPA's focus is primarily on documenting that Chrome-6 has the ability to induce genotoxicity. Following what is a genotoxicity hazard assessment, which is just one part of an MOA analysis, and I cite EPA guidance and TCQ guidance. Following what is a genotoxicity hazard assessment, EPA simply relies on genotoxicity as a plausible or possible carcinogenic MOA, stating, in conclusion, there's consistent and coherent evidence that a mutagenic MOA for Chrome-6-induced carcinogenesis is biologically plausible and relevant to humans. The primary basis for EPA's conclusion was simply a genotox assessment. Genotoxicity in some tissues equals biological plausibility, i.e. a possible MOA, and that equals a demonstrated mutagenic MOA in target tissues. EPA presented evidence for Chrome-6-induced genotoxicity, but no Chrome-6 specific evidence for establishing a mutagenic MOA past that. As Dr. Toby Rossman, a genotoxicity external expert peer reviewer in EPA's peer review workshop, points out, standard genotoxicity assays were not designed to inform specific modes of tumor induction. In summary, standard genotoxicity assays from hazard identification exercises cannot be used to establish a mutagenic MOA. The lack of Chrome-6 specific evidence for establishing a mutagenic MOA is clearly evident for the cancers made basis for the draft oral slope factor, where EPA's MOA conclusions rely on two factors. One, not all Chrome-6 being reduced extracellularly prior to absorption, and two, Chrome-6 exhibiting genotoxicity. EPA has conducted no analyses that show or suggest causation or dose response or temporal concordance between genotoxicity in the target tissue and the initiation of tumors in the target tissue. Although EPA recognizes the importance of conducting such analyses for supporting a mutagenic MOA. An important criterion in EPA cancer guidelines is, quote, similar dose response relationships for tumor and mode of action related events, end quote. Or, quote, dose response concordance, end quote. And a demonstration of temporality is the most basic of the Hill criteria. I can recall no Chrome-6 specific data that demonstrate a connection between genotoxicity in the target tissue and the initiation of tumors in the target tissue, which is contrary to the solid arrows shown in figures 316 and 318 and some other statements. Demonstrating mere biological plausibility is not tantamount to demonstrating an MOA. Indeed, EPA acknowledges that, quote, the specific role of Chrome-6 species and Chrome-6-induced DNA lesions in the toxicity and carcinogenicity of Chrome-6 has not yet been conclusively established, although, end quote, although the word conclusively appears to be unnecessary, as it appears from the draft that although Chrome-6-induced DNA lesions have been shown, no role has been established for any form of Chrome-6-induced genotoxicity in the target tissue carcinogenicity of Chrome-6. Again, there are no dose response or temporal analyses to even show concordance between genotox in the target tissue and the initiation of tumors in the target tissue. So, quote, is the key event associated with precursor lesions, end quote, which is from the EPA cancer guideline. That question, is the key event associated with precursor lesions, cannot be answered in the affirmative. Consequently, the draft must rely on assumption and speculation rather than such analyses. I assume that it's for this reason that the draft concentrates on genotox hazard assessment to draw the MOA conclusion at the end of the genotox hazard assessment. To then assume that genotoxicity must therefore be the carcinogenic MOA operating in target tissues requires a leap of faith I'm not willing to make due to both a lack of supporting data as well as it being contrary to good guidance on evaluating the potential for mutagenic MOA. And I'm citing EPA draft guidance from 2007 and TCQ guidance as well that adopts the principles in that document. Quote, the determination that a chemical carcinogen is capable of producing mutation is not sufficient to conclude that it causes specific tumors by mutagenic MOA, end quote. The apparent lack of data, such as dose response and temporal concordance analyses, that demonstrate a connection between genotoxicity in the target tissue and the initiation of tumors in the target tissue precludes any demonstration or conclusion that the carcinogenic MOA is a mutagenic one. Nevertheless, this hypothesis or assumption, unsupported by EPA acknowledged analyses relevant to demonstrating an MOA, some of which I mentioned above, was carried forward into section 3234, where it serves as the basis for EPA's assumed carcinogenic MOA. Dr. Toby Rossman, a genotoxicity expert on EPA's workshop, stated that, quote, there is no evidence for mutagenicity at the target tissue at all, end quote. Concurring is Dr. Sam Cohen, stating in totality, there is no clear evidence for a genotoxic response in the duodenum following oral administration of Chrom-6, end quote. Dr. Rossman similarly concluded, as I and other organizations and agencies have, that, quote, the evidence for mutagenic MOA is weak, with Dr. Cohen stating, quote, there's no question that the mode of action for Chrom-6 induced small intestinal tumors in mice is cytotoxicity with regenerative proliferation leading to the development of neoplastic lesions, end quote. It is noted that if Chrom-6 were to have a mutagenic MOA, then a carcinogenic response might well be expected in mouse and rat tissues demonstrated to have absorbed and retained significant Chrom-6 sources across all dose groups, and as early as by day 6 of exposure in the NTP studies, such as the kidney or the liver. Since significant absorption of a mutagenic carcinogen by multiple tissues of a species outside the portal of entry, and very early in a chronic study by day 6, should result in tumors at multiple sites in that species if mutation is the key event initiating carcinogenesis. EPA should explain this apparent discrepancy. By contrast, available data have led the World Health Organization, Health Canada, the Food Safety Commission of Japan, TCQ, and others to conclude that the weight of evidence supports a different threshold MOA. So EPA's carcinogenic MOA conclusion as it applies to the oral route is far from settled science, which at a minimum should be explicitly acknowledged in the main assessment. As the carcinogenic MOA is an obvious major area of uncertainty, its exclusion from more detailed discussion in the uncertainty section of the main document is not transparent or acceptable. Other organizations and agencies have concluded that the carcinogenic MOA has not been demonstrated to be mutagenic and that the weight of evidence best supports a different MOA. I go on to cite, as Dr. Morris said, some quotes from the recent assessment by the World Health Organization, a 2020 assessment, Health Canada 2016, the Food Safety Commission of Japan, et cetera. EPA's conclusions as to the carcinogenic MOA, as well as subsequent EPA modeling choices and assumptions, are at odds with these recent carcinogenic MOA determinations. And as a tier 2 suggestion, I state that EPA should reconsider its carcinogenic MOA determination. Additionally, moving forward, if a positive genotoxicity hazard finding in non-target tissues cannot be scientifically outweighed by the results from MOA-focused studies on the relevant target tissues in the species where tumors were observed and at relevant doses known to be sufficient to induce the MOA that induced the tumors, then it seems this would, could, and should be known prior to the conduction of any new MOA research. That is, EPA cannot exclude a potential mutagenic risk despite any MOA study results. If this is indeed the case, then EPA should consider explicitly stating this in revisions to the cancer guideline. Indeed, given that the mutagenic MOA conclusion was drawn at the end of the genotoxicity hazard assessment, it is unclear if past that point, any data could, quote, demonstrate that a mutagenic MOA could reliably be excluded, end quote. I have some additional comments that I have to cover as well. Scientific guidance for establishing a mutagenic MOA, again citing EPA and TC guidance, does not support a mutagenic MOA for carcinogenicity having been demonstrated, particularly for the oral route. For a chemical to act, quote, for a chemical to act by a mutagenic MOA, either the chemical or its direct metabolite is the agent inducing the mutations that initiate cancer, end quote. Mutagenicity induced by the chemical or metabolite must be the key event that initiates the carcinogenic process. Such a conclusion is not supported by dose-response concordance analyses of target tissue mutagenicity and subsequent tumorigenesis in those target tissues or temporal concordance analyses, the most basic of the Hill criteria. Section 3233 and the integration of genotoxicity evidence section seems to treat any demonstration of genotoxicity in non-target tissues in human populations exposed to Chrome-6 through inhalation as indicative of a mutagenic MOA for carcinogenesis in the small intestines of mice exposed orally. However, this type of information is wholly insufficient to conclude that Chrome-6 causes mouse duodenal tumors by mutagenic MOA, as it does nothing to demonstrate that Chrome-6 induces mutations that initiate these cancers. For consistency, EPA's de-emphasis of genotoxicity results in non-target tissue, applied by EPA in some cases, should be applied consistently across results. In the GI section, quote, rat small intestine is not a tumor target tissue, end quote, appears in comments for the Thompson et al. 2017 study, having the effect of diminishing the relevance of the results. Consistent with EPA's use of the quote, EPA should add, quote, not a tumor target tissue, end quote, in the comments for each study in the other tissue section and the test using Chrome-6 to induce genotoxicity section of table 319, as results from these studies, comprising most of the table, are also not in target tissue. Any genotoxic effects observed in these non-target tissues are of unknown relevance to the induction of cancer by Chrome-6 in target tissues. In the genes mutation section, discussion of Thompson et al. 2017, 2015C seems to diminish the relevance of the results by stating that, quote, inclusion of rat duodenal tissues in this mutation assay provides little value to mechanistic interpretation, given the small intestine is not a tumor target tissue in rats. I agree with the point EPA is trying to make, and so suggest EPA apply this reasoning across studies where applicable. Consequently, EPA should add text similar to the following to the discussions of all genotoxicity studies considered in the MOA analysis, not conducted on tumor target tissues for the tested species. Quote, evaluation of the tissues utilized in this study provide little value to mechanistic interpretation, given that the tissues are not a tumor target tissue in the species tested. This consideration appropriately recognizes that even positive genotoxicity results in non-ticket tissues provide little value to mechanistic interpretation. Non-target tissue results are low on the hierarchy of evidence for determining a mutagenic MOA, and I cite guidance. Additionally, in vivo MOA studies should not be devalued or rated low confidence by EPA for not including the MTD, as they are designed to inform the MOA operating at doses known to be sufficient to induce the MOA to produce tumors in laboratory animals, as opposed to being designed to more generally screen for genotoxicity hazard, even under the worst of conditions, i.e. dosing at the MTD. When attempting to understand the specific MOA that caused carcinogenic effects in a particular study, it only makes sense for studies focused on mode of action to use the same species exposure route and doses. If an even higher dose, such as the MTV, was not included in the positive carcinogenicity study, then whatever may occur mechanistically at such doses, but not at lower doses, is not required to initiate cancer and could even potentially represent a dose-dependent transition in mode of action. Results obtained at the MTD, but not lower doses, could be argued to have unknown relevance to the MOA occurring at lower carcinogenic doses. Several authors have suggested that exposure to high doses, such as MTD, may cause cytotoxicity leading to increased carcinogenicity due to increased opportunity for cancerous mutations to arise during regenerative cell proliferation. Gaylor 2005 is what I cite. But this cytotoxicity-driven process for generating mutations does not comport with the mutagenic MOA. Any positive results only occurring at the MTD would not be proof of a mutagenic MOA and might even be interpreted to support a different MOA, considering the following good guidance from EPA 2007. Quote, I provide a longer quote, but anyway, this is the important part. If mutations occur only above doses that produce cytotoxicity or other impaired cellular functions, the observed mutations may be determined to be secondary to other toxic effects. Similarly, the absence of mutagenicity at doses lower than those that cause cancer may suggest that mutagenicity is a secondary effect and therefore may suggest an MOA other than a mutagenic MOA. Again, the absence of mutagenicity at doses lower than those cause cancer may suggest another MOA. If, quote, the absence of mutagenicity at doses lower than those that cause cancer may suggest that mutagenicity is a secondary effect, then the absence of mutagenicity at doses equal to and greater than the lowest dose sufficient to cause cancer may certainly suggest that, quote, mutagenicity is a secondary effect and therefore may suggest an MOA other than a mutagenic MOA, end quote. This cited EPA mutagenic MOA guidance is consistent with recent genotoxicity guidance from IPCS 2020. It appears IPCS would urge caution in interpreting a positive response only at the MTD and not at lower doses, such as the carcinogenic doses in the NTP rodent and Chrome-6 MOA studies, which were still quite high. According to the guidance cited above, EPA is faulting the Chrome-6 MOA studies for not using a dose, the MTD, where any positive genotox results should not even necessarily be considered supportive of a mutagenic MOA, but rather could reasonably be interpreted to suggest that the genotoxic effects were, quote, secondary to the other toxic effects, end quote, and that the MOA is, quote, other than a mutagenic MOA. MOA studies that assess mutagenicity and genotoxicity utilizing the same oral doses that cause cancer in the same species. Data from those studies are most directly relevant, available to elucidate the culpable MOA. And again, previously I had suggested that EPA reconsider the carcinogenic MOA determination. I note that a major criticism in the draft was that while studies may have used the doses that produce carcinogenicity in vivo, the MTD was not used. While the use of MTD is important in genotoxicity to assess the question, does Chrome-6 have the ability to be genotoxic even under the worst of conditions designed to maximize the potential for a positive response, end quote, it is not the most relevant question for the MOA analysis. Good guidance in EPA 2007 emphasized that, quote, the determination that a chemical carcinogen is capable of producing mutation is not sufficient to conclude it causes specific tumors by mutagenic MOA. Rather, the more relevant question for MOA analysis in the context of a dose response assessment and draft carcinogenicity potency factor is more along the lines of what MOA was operating in target tissues at the doses known to be sufficient to induce the MOA and produce carcinogenic effects in the key animal studies. Consequently, not utilizing the MTD is a fair criticism of a genotoxicity study designed to more generally screen for genotoxicity hazard, even under the worst of conditions, but should not necessarily be viewed as a significant limitation in the context of the MOA study, given its somewhat different purpose and focus. Such MOA studies are better suited to provide the data needed for the types of EPA-recognized analyses that can help establish the MOA, dose response concordance and temporal analyses. These comments are consistent with those of Dr. Toby Rossman, who stated, again, standard genotoxicity assays were not designed to inform specific modes of tumor induction. By contrast, the Chrome-6 MOA studies were, which is again consistent with comments by Dr. Rossman, that for mutagenesis to be a carcinogenic MOA, the mutation should be induced in a concentration range with low toxicity, and the mutations should be induced in the target tissues in animal experiments and in humans. These should be early events. The Chrome-6 MOA studies clearly meet these study design considerations. Additional comments consistent with these were provided by Dr. Sam Cohen, indicating that one, when there is a known target tissue, the genotoxicity assessment is to be made at the doses used in the chronic bioassay showing carcinogenic activity. Two, it is inappropriate to use higher doses as the effect of genotoxicity at doses higher than the dose for carcinogenicity completely negates one of the fundamental standards for mode of action analysis. That is concordance between the dose of precursor changes, key events, and the dose response for the actual adverse outcome. And then three, thus for genotoxicity to be relevant to the carcinogenic effect, genotoxicity must be shown at the same or lower doses than the tumorigenic response. I agree. And as a suggestion, I believe that EPA would withdraw its criticism of the MOA studies for not using the MTV. Lastly, it seems that EPA's MOA assessment may be inconsistent with EPA cancer guidelines. The EPA cancer guidelines state the approach to dose response assessment for a particular agent is based on the conclusion reached as to its potential modes of action for each tumor type. And two, the approach for extrapolation below the observed data considers the understanding of the agent's mode of action at each tumor site. This language emphasizes the importance of tumor type-specific and site-specific MOA data in agency decision-making. That is, it emphasizes the importance of MOA data collected on the specific target tissues that develop tumors at a site. The understanding of the, quote, MOA at each tumor site, end quote, is inherently a function of the MOA data available for each tumor site. By contrast, for their draft MOA analysis, EPA lumps together information for different tissues and tumor sites. This appears inconsistent with EPA's cancer guideline. Accordingly, it's not clear that EPA's approach is tumor type specific and site specific as specified in the EPA cancer guidelines, or that it considers the understanding of the MOA for each tumor site that is inherently best a function of the MOA data actually obtained for each tumor site. And so that concludes the overview of my comments on question A.
And thank you. That was certainly a thorough coverage. Does anyone have follow-up questions?
I just,
To summarize in 3 bullets, because it was a lot, so maybe the most.
Actually, briefly, could you just give me the bottom line?
Committee members, I'm hoping that afterwards, I've been taking some notes, but afterwards, if you would send me sort of the key things you want incorporated. If it differs from what you've sent, that would be helpful. Otherwise, I'll, extract from what you sent. But that would be helpful, I think, for me and others to summarize things.
Well, the bottom line is that EPA has not demonstrated a mutagenic mode of action. I mean,
Yeah, I think we might have a difference of opinion on what's required. I'm not sure that the EPA should be expected to demonstrate conclusive evidence of mutagenicity to conclude that it might be involved. They certainly don't do that for most other compounds.
Yeah, I mean, so I do bring up guidance, what EPA guidances and other guidances have said about what's required, and that EPA acknowledges that for demonstrating mutagenic MOA, they talk about the importance of dose response analyses and temporal analyses. Okay, and neither of these can be conducted for the mutagenic mode of action because the data don't exist. So there's no way. So okay, fine. There's evidence of of course, that it's a genotox hazard, but the second part of it cannot be addressed. That the mutations induced by the chemical agents or its metabolite must be the mutations that initiate the cancer process. And that cannot be shown anyway because you cannot conduct even dose response concordance analyses or even a basic temporal analyses that shows there's any connection between the two.
So can I ask you a question? If a compound inhibits DNA repair and you get the mutation through DNA, from the lack of DNA repair for naturally produced, adducts that would appear if the DNA repair is not working properly, would you consider that a mutagenic mechanism?
That's a mechanism, but for demonstration of an MOA, you have to tie that event to the initiation of cancers, and there's no way to do that.
So that chemical, there are a lot of chemicals that inhibit DNA repair, and they're considered. I don't know. I think if you get mutations from an inhibition of DNA repair, it doesn't matter that the chemical itself didn't directly do it. It just matters that the cell can't handle the mutations it's producing as a result of that chemical being there.
Well, the thing in question here.
So I'm just asking you, what do you think? I mean, you can't keep going on the same. I mean, if you add a chemical, I don't care what it is, arsenic. Arsenic's an excellent example. This has all been shown with arsenic. It inhibits DNA repair, and you get mutations, and you get cancer. And without the arsenic, you won't get it. But the mechanism is different. It's an inhibition of DNA repair.
Under guidance, the question is, what can be shown to be driving this process in the target tissues? Can you show genotoxicity is driving this tumor
genotoxicity is there because as soon as the arsenic is there, the DNA repair stops, and there are if you don't repair the DNA constantly, you're going to get a lot of mutations and damage to the DNA, and you get, mutations from it and cancer. So if you inhibit DNA repair, you're doing the same thing as you were if you were directly causing the mutation.
One of my points is that for Chrome 6, although it's genotoxic, you can't tie genotoxic events in the target tissues to the initiation of cancer in those tissues.
The genotoxic, but the genotoxic events could inhibit DNA repair, which I believe does happen with Chromium 6. And so
yes, right. And so you're bringing up the possibility, and yes, that's fine to acknowledge that's a possibility because it's genotoxic, but just knowing that's a possibility and demonstrating a mutagenic MOA are two different things.
I don't understand your terminology. I mean, I think you have developed this as a sort of religion. And it's not, and you've got to fit in this particular religious situation to get mutations, and that's not the case. That's not the way science is.
Let's move on. Ivan, you had a comment then.
Yeah, Mr. Haney, maybe it will help us understand your interpretation that there has to be an equivocal link between a particular DNA damage by a chemical and then a tumor or initiating event. Maybe you can give us an example of a compound or treatment that you believe is operating under mutagenic MOA, or has TCQ ever classified anything as mutagenic before?
Yeah, we have determined that a mutagenic MOA is supported and apply ADS. I can't tell you the ones just right off the top of my head, but we have technical support documents on the internet. I think perhaps 1,3-butadiene is one. That's one of the first ones we turned out. I just don't keep that type of information.
So for butadiene, is there evidence of mutations in every target tissue that that has been linked to its carcinogenesis? Do you believe that there's of evidence?
Yeah, I can't answer that on the top of my head. What I can say is I've seen studies published wherein they do temporal concordance analyses and dose response concordance analyses between hypothesized key events and the induction of tumors, including for Chrome 6 for the alternate MOA, wherein they can show a temporal concordance and dose response concordance between events and the induction of tumors, and I've seen that for other chemicals as well. But yeah, I'm just not a person that's able to cite those sorts of things off the top of my head.
Thank you. And you've cited Dr. Rossman, I think 6 or 7 times in your comments. I was trying to figure out what his expertise is, and I think he hasn't published much in the last 10 or 20 years.
It's a woman, Toby Rossman.
Right. So, but it's Rossman TG at NYU, right? So I was trying to look up. So you said expert. Can you elaborate more on the expertise?
Not off the top of my head. I know that she's been used by several agencies as an external expert, including one in this case hired by EPA, and the TCQ had also she also helped review our own guidelines, where she was identified as an external expert by the organization that helped us coordinate the external expert peer review of our guidelines. But I've heard similar things from other people who other experts on mode of action, if you will. There's someone from FDA. I can't recall her name off the top of my head. I think also perhaps from Dr. Betty Meek, perhaps. I've seen different presentations where where folks who are expert in this field emphasize the importance of conducting these things, temporal concordance analyses and dose response concordance analyses.
Max, do you want to respond briefly on Toby Rossman's background?
Yeah, so I was her chair. I'm the chair of environmental medicine. She was in my department, and around, I forgot what age, but as she was approaching 70, she decided to retire. But Toby Rossman is a world leader in mutagenesis, definitely. She did a lot of great work and had a lot of grants at one time. But she basically hasn't been working for, I mean, she does these consulting things, but hasn't been working in academia for quite a while. I'd say about 15 or 20 years. She hasn't been in academia.
If I can weigh in on one thing that, just in general, there's no real accepted sort of structured way of determining whether a chemical works through mutagenic mode of action. The EPA attempted to come to a consensus, and the document's referred to as a draft guidance document because the EPA could not come to a consensus. There was a wide range of opinion, and so basically each committee goes forward, or the EPA itself has to make those decisions based upon the evidence they see. So although in an idealized world you might have this line of evidence, rarely do you have that in practice. And so that guidance document was never finalized because people could not come to agreement on what was expected, what should be expected or required. So that's kind of where we stand at the moment, at least from my point of view.
2008.
Oh, yeah, it's back in that 2007, 2008 period. And some of us lived through that, so I'm somewhat aware of this.
Yeah, and so I do cite that guidance where, because for one, TCQ has adopted the principles in that guidance and its own guidance, but two, I also, there at the last also cited inconsistencies with guidance in EPA's own cancer guidelines that are final.
Okay.
And I don't think the question here is whether Chrom-6 can cause genotoxin mutations. The question is, because the MOA analysis is supposed to be tissue and site specific, what is the MOA driving these tumors? And can you demonstrate it? Can you link that to mutation? And the data aren't available to do that. The only data that are available to do that are negative.
Okay, thanks.
And I just,
Oh, go ahead. Gloria wants to summarize her stuff, but go ahead.
I'm sorry.
Barbara. No, go ahead.
I just had a brief comment. We've heard some very interesting arguments from Dr. Weiss about localization of chromium in the crypts versus the villi, and I really look forward to seeing that information, and some very interesting presentation by Mr. Haney regarding mutagenic mode of action. And it just strikes me that I think we may wind up presenting both perspectives, but I do think that this also calls for consideration of presenting what are alternative modes of action that should be considered. And I know that we have one on the table, so it's just seems to me to present a full picture. We should also be, as part of the comments, considering affirmative evidence for modes of action other than a mutagenic mode of action.
Okay. Certainly, if anyone else, I mean, right now I'm aware of two that have some support. I don't know of others. Sort of like, I don't know of any hormonal or any other type.
I wanted to summarize my comments, but this is separate. I wanted to address what Dr. Beck just said. I think the EPA acknowledges both modes of action in the document and says there's evidence for both. But in the appendix, they actually have a lot about the regenerative mode of the other mode of action that we're talking about here, and they even developed, like, I think a reference dose or some kind of risk toxicity factor based on that mode of action in the appendix, so it is not like it isn't discussed in the document. I don't know if other people noticed that in the appendix.
Thank you, that's helpful.
Dr. Wise, did you have a
I
comment?
was just going to add a comment on the, the cytotoxicity mechanism that's been mentioned. And the two modes may be inextricably linked, as Ivan said. When we were one of Dr. Zikovich's lab and my lab were among the first to discover chromium-induced DNA double-strand breaks. And when my students would present this, they wanted to emphasize the importance of double-strand breaks. So they would always put up this slide that said, one unrepaired double-strand break is enough to kill a cell. Now, I used to say, you sure you want to show that? Because dead cells don't cause cancer. But the point being, the fact there's some cytotoxicity doesn't mean there's an absence of genotoxicity. That cytotoxicity may be produced from the genotoxicity. And in terms of alternative things to think about, I think Max touched on one, which is chromium clearly inhibits DNA repair. Now, whether that gets lumped in as a mutagenic mode of action or whether that's a different mechanism, I'm not sure. There's also epigenetic changes that are certainly coming into play. So, I mean, in a way, when we do these risk assessments, we sort of live in this artificial world of it's A or it's B, when really it's all of it kind of tied together, and how it ties together becomes an important part of the discussion.
So Dr. Haney argued that EPA did not show that mutagenic mode of action produce lesions or mutations which leads to cancer. Therefore, mutagenic mode of action should not be applied. While it's an alternative model of cytotoxicity-driven regeneration leading to cancer, what is the evidence that that mechanism produced cancer-initiated lesions? And there are no evidence. It's actually a much more poorly supported model. And I'm not excluding this mechanism, but I'm much more skeptical than other people. And my argument is, if you look at dose response, tumor versus chromium dose, epidemiological studies for the lung, different studies, not only GIPS, which EPA used, it's actually linear. So if it's a cytotoxicity-driven mechanism, you would expect sublinear mechanism, because low dose of chromium are not going to cause much toxicity, and therefore there would be not much of regenerative proliferation leading to cancer. If we look at animal data, small intestine, especially if you combine female and male, it's also linear. It's not sublinear, because from cytotoxicity-driven mechanism, you would expect sublinear mechanism. It does not operate where you have a statistically significant elevated incidence of tumors. And nobody explained from a group who supports cytotoxicity-driven proliferation as a mechanism, how it actually leads to cancer in terms of induction of mutations. Because cancer, again, is a genetic disease. You cannot really avoid the question of origin of mutations. You can exclude direct genotoxicity, but then you have to explain how mutations actually arise. And we know now that proliferation itself is not a major source of mutations. There is lots of published data now. If you look at test sperm production is a massive proliferation event. It's a very, very low mutation frequency there. If you look at small intestine as an example, it's comparable to tissue which don't proliferate very fast, for example, like in the liver. If you look at hematopoietic stem cells, bone marrow, high level of proliferation, rate of mutation similar to prostate. If we look at the human cancer, what is the #1 human cancer in male? Prostate. Even though rate of proliferation is very small, small intestine, very high rate of proliferation, it's not in the top 12 in human cancer. I don't know, it's actually very, very low. Just simply by boosting a little bit proliferation, and boosting a little bit spontaneous rate of mutation because of a number of proliferative events, it doesn't mean it's going to lead to cancer. So I actually would like to hear somebody explain to me what is the evidence that cytotoxicity-driven proliferation operates here even. Not that, I'm willing not to exclude it, but nobody will actually presented the evidence that operates. Dose response is linear, not sublinear. And what is the origin of mutations?
Yes, I'd like to try to address some of this. I showed, well, I didn't show earlier. I referred to earlier in comments, graphs, benchmark dose modeling charts in my comments, they're inserted there, which shows the dose response data for tumorigenesis in males and females. And when you look and see how to best connect the dots, if you will, the line, the line does go sublinear at low doses. Now, EPA just fit a linear model to it, but for example, when you actually look at the data, you can see that there's a sublinear component to it. If you connect the dots in the best way possible. So now, in terms of, well, what data supports the alternative MOA? Well, there's been many papers published that support the alternative MOA. In those papers, there are analyses of temporal concordance and dose response concordance. And so I cite some of those in my own comments. That's going to include some of the papers that have been reviewed, and it's going to include one of my own papers where at the very end of my last paper, I'll walk people through what I see is temporal concordance and dose response concordance. So now, but the thing that I pick up on in your comments, as it seems to be that they present a choice, which is EPA has to say either the MOA is sufficiently demonstrated, or they have to say that the cytotoxicity MOA is sufficiently demonstrated. They don't have to say that either is sufficiently demonstrated. So it's a false choice to put it that, well, we have to come to some consensus that some MOA is sufficiently demonstrated. I've pointed out facts and guidance where I think it shows that a mutagenic MOA certainly has not been demonstrated, and other people have expressed concerns about the genotox studies and other studies conducted or coordinated, that is, by tox strategies, and so they have concerns about those studies. No one has really even broached the possibility that neither EPA nor us have to say that any MOA has been sufficiently demonstrated if we can't come to a consensus, right? And so, we all know what our different positions are at this point, but I just want to put that out there that because of the lack of consensus, the SAB does not, I don't think has to say that any MOA has been sufficiently demonstrated, despite what's in the draft and despite what other agencies have determined as being sufficiently demonstrated.
So I want to, one last point. A very popular thing to do now is to sequence tumors, because by looking at the sequence, you can tell what caused the tumor. And I bet you it would be, this would be one way to answer the question, is if you took a bunch of tumors induced by chromium and sequenced them, do you see a certain sequence change in all those tumors? And this is doable now because sequencing has gotten so inexpensive, and people are doing it all the time. And what they do find is that they can tell mutational signature from the agent. that's coming from from their exposure to a particular agent. And that's been published in lots of good journals in the last couple of years, and it's becoming more and more popular. And I think you could answer this question by doing those experiments.
Dr. Wise?
Yeah.
Yeah, I just want to reflect back one of Mr. Haney's comments to him because I'd like to hear I'd like to hear his thoughts on this. But he just, as you were just saying, it may be that no mode of action has been demonstrated. So assuming that if we came to the conclusion that no mode of action has clearly been demonstrated, how does EPA do its risk assessment?
It's a linear extrapolation.
Right, that's.
You're muted, so we can't hear you.
You mute it.
Yeah, and so it normally goes to default procedures, right? Which is linear low dose extrapolation, which, you know, the default procedure is not, any different in terms, of the low dose extrapolation. However, also there are toxicokinetic data that, in my mind, again, like I covered earlier today, indicate that the toxicokinetics of it aren't linear, that there's that a decreasing fraction of the oral doses is absorbed and retained as the oral doses decrease below the point of departure. So, certainly in my mind, as expressed in my comments on a later question, the toxicokinetics of it alone are inconsistent with linear low-dose extrapolation, because linear low-dose extrapolation overestimates what the target tissue concentrations and therefore the excess risk would be.
Yeah, and we'll get to that later. I'm actually interested in hearing what Dr. Post has to say, John, if you're okay with that.
John, you may want a quick question, and then I'll have Dr. Post summarize.
I was just saying, wouldn't toxicokinetic considerations also fall under a hazard assessment much?
That's
Not under mode of action.
dose response, maybe? That has more to.
Yeah. Well,
I have to do with the shape of the low dose extrapolation.
Yeah. Well, in terms of hazard, if you're talking about the tox factors, are you talking about the tox factors based on non-cancer effects?
Yeah, I was referring to your specific answer.
Yeah. So the implications for sublinearity of target tissue dose for non-cancer effects would be that as you divide the point of departure by uncertainty factors to produce lower and lower doses, if you will, the sublinear nature of the target tissue toxicokinetics, as I see them, again, you know, that's not what I do as a matter of discipline, but that I found in the data would imply that the RFDs, if you will, the safe doses are just all that much more safe.
Dr. Post, would you summarize?
I just wanted to summarize. I wasn't assigned to this question, but I submitted some comments, and I just want to briefly summarize them. So basically, what I agreed with what Dr. Weiss, Zitkovich, and Rusin said at the beginning of this discussion about the mode of action, that it's mutagenic, and also the issues about why the in vivo oral genotoxicity studies were low confidence, that besides that are separate from the MTD issue that Dr. Wise explained just now a little while ago. But I just want to also, it's in my comments, the draft document does state, in addition to the saying there's evidence for mutagenic mode of action, that there is evidence for regenerative hyperplasia as a key event for tumors of the small intestine, and that multiple this is a quote, it's in the appendix, maybe it should be in the main document, appendix page D31, lines 4 through 5, multiple modes of action for tumor formation in the mouse small intestine could be occurring in parallel. I think Mr. Haney was, or someone was saying maybe we should talk about multiple modes of action, but it does say that in the document. It specifically already says that. As far as having to show genotoxicity in like every tumor type, I don't think that's standard process for the other chemicals that EPA's concluded is have a mutagenic mode of action, because in my answer, when I was looking into the ADAFs, it's part of my answer to part B, which we'll get to. I actually went back and looked at all the chemicals that IRIS has used ADAF since the ADAF guidance came out in 2005, and because I wanted to see, I was interested in the oral mode of action analysis, and if ADAFs were supported by the guidance, since it's not for inhalation, it's very clear it's genotoxic and mutagenic, and I don't think that they looked at like all the tumor types when they concluded there was a mutagenic mode of action for the 8 other chemicals where they've applied ADAFs, and that's not needed. I had a couple other comments that aren't about this specific thing about the small intestine tumors, but they're for this section, and one is relating to the mode of action for the oral tumors in the rat. It says in the document, as a quote, there's no evidence to conclude regenerative hyperplasia is involved, and it also says in the appendix that the tumors of the rat oral cavity don't have a proposed mode of action, but from everything else I read about the oral cavity tumors, it seemed like my interpretation is EPA was concluding it does have that they have a mutagenic mode of action. So I'm suggesting that where it says they don't have a proposed mode of action, that be clarified, because I don't think it's consistent with what's said elsewhere. And I just have one more comment about the 10 key characteristics of carcinogens that they used, and the citation, I believe, is Smith et al. 2016. In the ORD staff handbook for developing IRIS assessments that was finalized last year, that citation and the 10 key characteristics are mentioned as an approach to be used. So I thought it would be helpful to mention in the Chromium document where they're used, that they're recommended, or whatever, in the IRIS handbook, which was finalized recently. And then there were other ways that other citations for hallmarks enabling characteristics of cancer by Hanahan and Weinberg, and it wasn't clear to me if that was specific for Chromium 6 or if they're used by IRIS generally. They weren't mentioned in the handbook. It did say there's other similar approaches, so I was just suggesting that be clarified. And I have some other edits and clarifications that I don't need to go over. Thank you.
Let me point out one more thing, because I did comment that maybe the cancer guidelines need to be changed. If positive genotox results is that, if that's all that we need to demonstrate a mutagenic MOA, well, that was known back in 2010, and so knowing that, if any new MOA studies, if those results could not overcome the positive genotox data, well, then that should have been known back in 2010. And so since then, 13 years have gone by, a lot of funding's gone by, a lot of animals were used in these studies, et cetera. And we're in the same position we were back in 2010. If that's the scientific standard for demonstrating mutagenic MOA. And so certainly if that's the case, the EPA guidelines should be revised quickly to state that. So it's clear to people that are interested in conducting new MOA studies.
Mr. Haney, let me respectfully disagree and read to you from the 2005 guidelines that say that evaluation of in vivo or in vitro short-term metabolic profiles, physical properties, structure-to relationship, weight of evidence approach, key data may include DNA adducts, different genetic endpoints, and so on and so forth. And that's exactly the type of evidence that was mentioned by the primary reviewers of this question, that there is a variety and a large plethora of evidence, that it's not just simply Ames mutagenesis results, as you seem to pretend, that provide sufficient evidence. It's evidence in simple models, it's evidence in animals, it's evidence in humans, and it's also the knowledge of metabolism and toxicokinetics and toxicodynamics of this particular compound that together lead one to conclude that mutagenic mode of action is likely to operate in every tissue. So I don't agree with your point that we only are relying on genotoxicity and thus calling everything mutagenic. So I think this is not true.
Yeah, I appreciate your comment. It's not quite as simple as stated. So given what you just read, still I think something could be added to the guidelines, which make it clear that given circumstances such as these, however you want to characterize the genotox data, once that's been met, once that's been established, then EPA considers that sufficient, and so that's sort of the end of the MOA analysis, if you will. I still think that there would be value in letting people know that in a more nuanced way, as you're alluding to.
So, any more discussion on this point? Edwin? No. Just kidding. It seems to me that we're probably have aired a wide range of opinions on this, and the key element is to kind of get a feeling for the committee in general. I don't know if we need to do it at this point on whether the evidence is sufficient to support a mutagenic mode of action, or whether, you know, there's support for two modes of action occurring simultaneously, or primarily this cytotoxic regenerative hyperplasia mode of action. And it might be useful for me, and then I'll probably be writing this up, to get a sense from people just to get a sense for how strong the support is from the general committee for the mutagenic mode of action based on the evidence we've discussed.
Can we maybe be very specific with the charge question, because it says that EPA concluded that mutagenic MOA is sufficiently supported in laboratory animals and relevant to humans, and that the determination applies to both oral and inhalation exposures. I mean, that's, I think, is important for us, that it's not saying that it's conclusive, it says that it's sufficiently supported and it's relevant to humans, and by both oral and inhalation routes. That's the conclusion that they drew.
Yeah, that's correct, and that's probably what we ought to get a sense from people, if they are in agreement with that statement or if they disagree with that statement. Anyone want to weigh in? I mean, I guess,
Why don't we have a vote?
Yeah, let's just do a straw vote, see where we are.
Support a conclusion as written there, as read by Iverson.
Yeah.
Those in favor of that conclusion, the EPA's conclusion, please show by raising their hands. Okay. Those opposed? Okay. Okay. Was there?
So for those of us on the other side of electrons, how did that come out?
Okay. As the, don't think it's supported. Okay, okay, that's helpful to know.
John, it's, yeah, everyone but 2 feel it's supported.
Okay.
All right.
I think, so I'm trying to decide how we proceed. I think we can reflect that in the write-up. Dr. Eastman, are you comfortable with that?
Yes, and that's what I was trying to do, is at least show there was a strong majority supported this approach. And I mean, that's, I think is helpful, and helpful for the EPA to know as well. Now, so the next question really is part B, and I don't know if we should take a break now, or if we should go on.
What are people's feelings? I think we might deserve a break right now after that hour, 45 minutes.
That we should take a break now, and should we go plan on getting back at, say, 3 o'clock? Okay.
3 o'clock.
Yeah, we'll recess until 3 o'clock. Thank you.
Are we all back? Looks like we're getting there.
Almost, just give them one more minute.
I didn't have far to go.
Okay, let's take our seats, please, and we can get started. Dr.
Okay.
Morris, take it away.
Yep. Just a couple of things. You know, we have all morning set aside tomorrow, so we don't have to finish this tonight if we start hitting the wall, which we might at some point. So that's something to consider. And if we meet tomorrow too, that would give a chance for the discussant leaders to bring up any questions they might have about tier 1 versus tier 2 comments while we're all together. You know, if there's any lingering questions, we'd have a chance to go over them. The other thought that I had is I recalled yesterday that we had said we would consider on a case-by-case basis whether papers should be removed just because they did not use the MTD dose. Is that something we wanted to get back to? And if so, should we do that now or put it off and maybe forget? It's up to you guys.
If I can clarify, people are saying the MTD dose for convenience. It's actually in standard genotoxicity testing, particularly when is to go to a high enough dose where you see toxicity. And but it's not the traditional maximum tolerated dose we think of from a chronic bioassay. This is just you push the dose to a level so that you're confident that the chemical got to the target organ through some measure of toxicity. I think that's what they're referring to. But, and I mean, we could address it as indicated, I indicated in my comments, I think you can ask for too much to go. So for example, if someone has selected their doses to mimic those that were used in the National Toxicology Program's bioassay, because they're trying to model their stuff exactly with that, they don't really need to go to a higher dose because there's a rational reason they've chosen those doses. And for me, that's acceptable. But if they're just choosing any dose, there ought to be a reason for that dose. And if not, they should go to high enough so that they've seen toxicity.
So I interpreted their comment a little bit differently, not a lot differently, just a little differently. And to me, an important component of it was the data were negative. And so they're saying, well, the data are negative and you didn't reach a cytotoxic threshold. So how do we know the data are actually negative?
Well, yeah, and that's the critical thing in most testing. You have to go high enough dose to prove that they got to target organ, so you would have seen something. Otherwise, you could say, well, you tested it was negative, but if you had gone to a higher dose, you might have seen something. And that's, right. So I agree with you on that.
Although I guess here, they tested at doses where they saw tumors. So there.
Yeah, I just meant.
I think, and I thought those were the studies that we're talking about that were downgraded because they didn't achieve the MTD, but they were conducted at doses at which tumors and cytotoxicity were observed.
Yes, by a different study. So what I'm getting at is, if you look for, and I don't remember the exact paper, so I'm just picking one at random. And so if I have the paper wrong, that's not I'm not trying to criticize the paper here. But if you look at the mutation assay study, and it's negative for mutations, is that because it's negative for mutations, or the assay's too insensitive?
Right, but I guess
You'd have to have now in that instance, I think they have a positive control.
This is different because here it was below and at, and I'm trying to remember if they even had samples, doses of, do you remember, did they have doses above the initial tumorigenic dose as well?
I don't recall, but I don't think so, because I think they were specifically trying to say what's happening at that dose where we saw tumors.
Right.
And that's a valid for me, that's a valid study design.
Right, in this context.
Yeah,
I
in this
agree. Yeah,
context.
Yeah. So are we?
Yes, I mean, to add to that, it looks like, because they relied on the carcinogenic doses, I mean, it looks to me like epithelial hyperplasia began at the highest dose as early as day 7, certainly by day 90 at the next lower dose. So, these cytotoxic effects on hyperplasia begin to occur early on at the higher doses and occur at lower doses with longer exposure, like the 90-day exposure. So it doesn't seem to me that there's a question that Chromium 6 is getting to these tissues.
Dr. Marfus, do others want to weigh in? I mean, if I were kind of recommending, I would say we probably should not weigh in formally on this, because I think there are enough judgment calls that have to be done by EPA in reviewing and evaluating. But I think, we might weigh that some comment like if there's a scientific justification for deviating from sort of a standard testing protocol, that should be acceptable. But if not, then you would accept sort of standard approach.
Yeah, I would just want to, for me, I would like to review the specific examples again and then.
Okay, you bought yourself an assignment, John.
You're too kind, John, you're too kind.
I just didn't, we had said we'd get back to this, and I wanted to make sure we didn't drop it. I remember Dr. Post's comment that those papers that were given low confidence were given low confidence for reasons in addition to the dosing concern, which I think would be relevant in this discussion.
Dr. Wise, really, that was the stuff he was explaining all about the problems with that not being a standard assay for the gastrointestinal. Those were the papers, I believe, the same papers, and he went into a lot of detail a little while ago about the problems or the issues.
Yeah, he's correct in that if you don't, because these are so experimental, you don't really have very good positive control. So it's very hard to interpret when you get a negative result. Is that a true negative, or is this just because something wasn't designed properly? You didn't test for long enough, or you didn't score enough cells, or your scoring criteria were not adequate, et cetera. So it's tricky. It's a difficult situation.
Well, EPA can withdraw one major criticism of these studies if it's not justified. That's fine. That is this MTD dose issue, and while still retaining other criticisms of the studies.
But I don't think we have a charge question related to this. I don't think, the getting SAB weighing in on the merits of a particular criticism is way beyond our charge.
I think one of the charge questions may touch on this, but what I would propose so we can move forward is I'll just look out for comments about this when I am going through all of the discussant leaders' reports. And if I have a concern, I'll raise it to the committee downstream. Hearing nothing, let's continue.
Okay, so let's move on to charge question B, and I'll read it. Because tumors in rodents and humans were observed in or proximal to portals of entry where cellular uptake of chromium-6 may occur prior to detoxification to chromium-3, and because a mutagenic mode of action for chromium-6 carcinogenicity is sufficiently supported in laboratory animals and relevant humans, EPA applied a low-dose linearity approach for both the oral and inhalation routes of exposure. In the absence of chemical-specific data to indicate differences, that's the first point. In the absence of chemical-specific data to evaluate differences in age-specific susceptibility, increased early life susceptibility to chromium-6 is assumed, and EPA applied age-dependent adjustment factors, ADAFs, in accordance with the supplemental guidance for assessing susceptibility from early life exposure to carcinogens. So really there are 2 points here. One is the acceptance of low-dose linearity, and the second one is the use of age-dependent adjustment factors. Both of these are triggered usually by a conclusion that the agent acts through a mutagenic mode of action, but they don't necessarily have to be. Okay, so would anyone like to weigh in on this? I can certainly go on, but we'll let some other people talk and I'll weigh in at some point.
I'll weigh in. I agree with the toxicokinetic arguments. I don't, since they make the point that it's the transporters that get the chromium-6 into the cells, at very low exposure concentrations, there's going to be competitive inhibition, and the phosphate and the sulfate's going to be filling up those transporters. So that's pretty straightforward, pharmacology. So I would think that needs to be considered when they're doing a low dose extrapolation. That shouldn't be too tough, but they need to provide a justification for why they're not going to do that.
Yeah, Dr. Zitkovich?
Yes, so the argument about competition from sulfate, phosphate, which was also made by Dr. Eastman, it's logical if you look at the description that chromate enters through sulfate channel. To strengthen this argument, somebody has to bring evidence that, yes, we add sulfate or phosphate in the presence of excess of those, chromate is not taken. I'm going to disclose it in a private discussion, but in this room with Dr. Eastman, I already brought the fact that one of the common tissue culture medium, RPMI 1640, has 5 millimolar phosphate, 0.4 millimolar sulfate, but we can add 1 micromole, 2 micromole of chromium, and within a couple hours, we can readily measure chromium-specific effect, chromium adducts, DNA damage activation. So we have more than 1,000-fold excess of so-called competitor, but we still have chromate in cells and so on. So I don't have easy explanation why there is no competition. Possible that it's not really what transporters take, it's ionized form, and usually sulfide phosphate are bound by magnesium ions, and therefore they're not really effectively competing. So it's logical to raise this question, but to make an argument without actual reference paper saying, yes, in the presence of a certain amount of sulfate phosphate, there would be inhibition. So what is the evidence that actually this inhibition takes place? Because not in cell culture, and how much of that sulfate or phosphate actually is present in small intestine under typical exposure? Otherwise, it's only theoretical argument or possibly a question, but not with experimental support.
If I can weigh in, I mean, that was one point. And my recommendation was to have the EPA look at this and see if they thought there was merit to it. The other points on this were, as you go to, we're used to thinking in sort of the experimental range where we have the data, but we have a model, essentially this mode of action. And now we have to say, what happens when we take what we know, these pieces, and go to really low concentrations? Because this extrapolation is where we're going, is to extremely, extremely low concentrations with chromium. And when I looked at this and I started thinking about this conceptually, one of them is you get this sort of situation where diffusion, as I mentioned before, is driven on a concentration gradient. Basically, you go from a concentration, high concentration, low concentration. So when you go to really low concentrations of chromium-6 in the water or the diet or something, the pressure, the concentration gradients can be very low, so you're going to have slower diffusion, which should allow more time for certainly the reduction to take place. And one of the problems with reduction is you may not have sufficient time, but this should allow more time for reduction. You have very low levels, and so I would expect reduction to be fairly efficient at this point, so that the chromium-6 would not be taken up by the cell. Plus, you have this potential for, competition from phosphate and sulfates or whatever other anions may be competing. So that might slow the uptake as well, and that, for me, would argue that at low doses, you could easily see, threshold types of approaches, a nonlinearity that would play out. As Mr. Haney mentioned, there is some evidence, at least in the modeling, that the proportion that gets absorbed is decreased at lower concentrations. And I'm not sure on this, and then effectively, as I said before, once it gets taken up and it goes in the cell, the reduction, intracellular reduction, is a bioactivation process. But ultimately, you're generating chromium-3, which is not nearly, from my perspective, at least in your cell culture studies, as genotoxic as chromium-6 is. Now, I defer to Dr. Zitkovich or Dr. Wise, who may have done comparative studies, but that's my impression.
Are you referring to chromium-3 administered extracellularly, or are you referring to chromium-3 inside the cell?
Well, presumably it's got to get in there somehow, because it's getting in, right?
Right, but that goes back a little to when you were talking about the chromium picolinate, which is the chromium outside the cell is a big bulky molecule because it's bound to lots of things, and it doesn't get in very well. It's it'll get in by simple diffusion, but you're talking days before it gets in. But inside the cell, when it's reduced, it's not bound to anything, so it can bind to whatever there in the cell. So they're very different in that respect.
Okay, well, and that may be the case. So, this comes back to this idea that chromium-3 has historically been thought to be essential nutrient. It may not be, there's a lot of question about that, but it's in this sort of gray zone.
But a lot of that is considered to be an extracellular effect, binding to receptors outside the cell.
The chromium-3? Oh, okay. I appreciate the update on this. Sorry, Dr. Zitkovich. Oh, so my take on this is there are enough steps which would suggest really efficient detoxification would occur prior to getting to the cell, that this could easily argue for a nonlinear approach in this case. So there might, in my mind, I think it's certainly worth having EPA look at this in more detail to determine whether they think they should automatically go to the linear approach, or, as I indicated, they can deviate from the linear approach with a mutagenic mode of action if they determine that at lower doses, different processes are involved that may indicate that's not necessary.
Dr. Eastman, I've found your comments very interesting in the context of my own, which I think might be a good time, given your comment there to chime in with. And so my own comments are that the draft assessment indicates that a gastric PBPK model of the stomach was used to estimate the chromium-6 dose escaping stomach reduction. And so that adjusted daily dose was the basis of their quote unquote internal dose metric. For dose response modeling, and the draft assessment further indicated that stomach PBPK modeling of reduction in transit is sufficient for use in dose response modeling without incorporating uptake kinetics. And then I note that figure C12A of the draft shows that the internal dose used by EPA is essentially linear from higher to lower oral doses. However, me personally, I find it difficult to support a dose metric or extrapolation approach for estimating excess risk that doesn't reflect the apparent non-linear dose dependence of chromium-6 absorption by target tissues, which I've talked about today. Target tissue chromium-6 absorption, the actual causal determinant of excess risk, as all key events shown in figure 316 of the draft occur following cellular uptake, and excess risk is proportional to target tissue absorbed dose, is dose dependent, with progressively smaller fractions of the oral dose being absorbed by mouse target tissues as oral doses decrease below the draft oral slope factor, POD. So I provided an example figure which captures the draft oral slope mouse POD dose and the dose at the MCL, and show how the dose fraction absorbed at the draft oral slope factor POD is higher than at lower doses such as the MCL. So that's in my comments. Also provide a table to help discuss a duodenum specific example. And what it shows is that linear extrapolation gives rise to a fourfold excess risk overestimation at the MCL when assuming low dose linearity. That is, target tissue dose is overestimated by fourfold. I provide some figures in an appendix to help visualize the data, and also within my comments. And also state that consideration of all three tissues, duodenum, jejunum, ileum, result in a similar overestimation at the MCL, a 4.3-fold overestimation. And that EPA's internal dose metric of the dose escaping stomach reduction does not reflect this nonlinearity in actual target tissue absorption, most specifically below the mouse POD dose, from which excess risk is being extrapolated to lower doses. It's also important to recognize that target tissue absorbed dose overestimation, and therefore excess risk overestimation, becomes progressively higher as doses progressively decrease from the mouse POD dose, with the implication being that dose-dependent non-linear target tissue absorption for Chrome-6 at doses below the POD is inconsistent with linear low-dose extrapolation. Linear low-dose extrapolation results in an overestimation that increases as oral doses decrease to more environmentally relevant doses. Arguments that support non-linearity and toxicokinetics, namely stomach reduction kinetic non-linearity in mice and humans from higher doses to lower doses, that by corollary affect target tissue dose and support a commensurate non-linearity and extrapolated excess risk, are also provided in public comments. And I put a footnote in there of where those public comments that support non-linearity below the POD are provided. And I cite EPA guidance where the cancer guidelines, where EPA acknowledges that non-linearity in dose response can often result from toxicokinetics, and that would appear to be the case here. And so higher to lower dose non-linearity in target tissue absorption and excess risk should be reflected in the extrapolation approach, I believe. And so I believe EPA should reconsider the low dose extrapolation approach. I also reiterate some comments about the dose metric. And, while modeling absorption by target tissues may have associated uncertainties, as they outline in table C10 of their document, uncertainties are inevitably present in multiple areas of dose response assessment. But absorbed target tissue dose should generally be viewed as a better and more desirable dose metric for dose response modeling, as it is truly the internal dose most proximately and causally related to tumorigenesis observed in an NTP study. And so, from my perspective, for risk estimates to be considered scientifically defensible, non-linearities and toxicokinetics need to be appropriately accounted for in the EPA method ultimately used for estimates of excess risk. And then I provide some benchmark dose graphs that I provided before, showing the actual dose response data in male mice and female mice that do not appear to provide strong support for linear low dose extrapolation, but rather visual inspection reveals that non-linearity is present. And I believe that the assessment should rely on analysis of the data rather than general defaults. And that in contrast to reliance on defaults, when data are sparse, the EPA cancer guidelines indicate that when more data are readily available, a critical analysis of all the available data available can be used as a starting point for the assessment, which in the present case includes those data supporting the nonlinear extrapolation of excess risk from higher to lower doses. And then lastly, in regard to the ADAF adjustments, I cite comments from the New Jersey Department of Environmental Protection with a suggestion that EPA should clarify the practical significance of the ADF adjusted SFO. And so that concluded my comments on this question.
Thank you. Any additional comments?
I'll just throw in, I'm comfortable, Dr. Eastman, with your suggestion that we just say this needs to be considered.
Okay.
Right, and justified. I'm very comfortable with that.
Okay.
Are we speaking, I think, specifically about the gut, not the respiratory tract? We should try to be specific if we're recommending this for both or just one. I think it's only the gut.
It's primarily the intestine, although you can make some of the same arguments for the inhalation, not as easily though, because of the, the close proximity between the air and basically the respiratory tissue. There's the thin fluid there, but not as much. So.
And a lot more phosphate in the diet than the air.
Yeah. Okay. All right. Yeah. Dr. Zitkovich.
So I'm going to bring some chemical arguments against common sense, which people would consider. That the ratio of reducer to chromium impacts how effectively chromium is detoxified, not as a percentage. So in small intestine, it's a neutral pH, so the only reasonable reducer for chromium-6 can be vitamin C, ascorbate, because glutathione, even if it's present, it's really lousy reducer at neutral pH. So my group, other people who published earlier, Ken Wetterhahn, some other better chemists than me, define reaction between ascorbate and chromium-6 as a first-order reaction. The fundamental property of first-order reaction means that rate of reduction is independent on chromium concentration at the conditions when ascorbate present in 10x or more. So if we have 1 millimolar ascorbate, if we have 10 micromole chromium, 1 micromole chromium, 0.1 micromole chromium, half-life is the same because rate is determined by the most abundant component, which is ascorbate, present in 1 millimolar. And therefore, arguing, a low dose of chromium-6 will be much more quicker detoxified because of ratio. It's not ratio which determines a rate of reduction. It's a concentration. Now, it's a chemical argument. I'm going to bring argument with experimental evidence study, which was not included by EPA, but done in 60s. Nothing like this can be done now because they use radioactive chromium and inject it to volunteers in the small intestine and in the stomach. So they took 20 nanograms of chromium, radioactive chromium. 20 nanograms, to give you an idea, it's 5,000 times less than amount of chromium in 1 liter at MCL concentration. So MCL concentration, this currently is 100 micrograms per liter. So this is 20 nanograms, 5,000 less. And nevertheless, they got 10% excretion through urine. And if it was chromium-3, you wouldn't get 10%. 10%, it means chromium-6 was absorbed. So even for 20 nanograms, there was not enough stuff in the small intestine to either block its uptake or to reduce it. So please do not exclude chemistry. Somebody in 2011 panel said that when I made the argument about chemical law, said that chemistry rules do not apply to biology. They do. So if somebody wants to claim that somehow chemical law here does not apply, I will be happy to hear.
Any other comments? Let me move on to the, well, we'll come back, but does anyone want to make some comments about this age-dependent adjustment factor, which is the second half of this?
I did,
Okay.
but that's separate from what we were, it's like a separate part from the first part of Part B, so that's why I was waiting. So basically, if, when EPA or IRIS uses a cancer slope factor approach, that could be because we know it's genotoxic, it's established, or if the mode of action is unknown, that's the default. So the age-dependent adjustment factors are applied when it's established that there's a mutagenic mode of action or when there's evidence for it. It's not automatically applied when there's a slope factor approach, and it's based on evidence from certain chemicals that the information, the data is summarized in the guidance talking about this, that when there were studies where, like rat studies, chronic rodent studies where exposure was started very early in life for this, and then they had other studies where it was started at the normal age of young adult animals, that when they were the chemicals that were mutagenic, there was higher susceptibility early in life. That's what it's based on. So it's not automatic like when there's a slope factor used. So for inhalation, it's pretty, I think it's quite clear that, or the mutagenic mode of action's really well established, so I didn't think there was a question on that. But for the oral, I wasn't quite sure, like, what evidence EPA needed of how strong the evidence for mutagenic MOA to apply the ADAFs with a slope factor. So I, myself, just for my own personal use, looked at all of the 20 carcinogens that IRIS has developed cancer slope factors or inhalation unit risks since the time that in 2005 when the ADAF guidance started being used. So it turned out there were 8 carcinogens where they did apply ADAFs, that 8 IRIS assessments for carcinogens where they were applied with and 12 where they weren't applied that also had slope factors. And I looked at the explanations that they provided for applying them or not applying them, and it seemed like the available mode of action data for Chromium 6 for mutagenic mode of action, in my opinion, did indicate it was consistent with reasons for other chemicals, the level of evidence where they did apply ADAFs to the oral slope factor. Some of the ones where it wasn't applied were the clearly non-genotoxic carcinogens that might act through receptor activation or something, and there was no mutagenicity or genotoxicity data that was positive for those chemicals. So that was what my evaluation of that was. I have other comments on it, but that falls under other parts of this question later.
So perhaps I missed it. So you reviewed all these other examples when they had identified when they had applied an ADAF.
Or did not.
Or did not.
Right, and in all of the other IRIS assessments that have had cancer slope factors since the guidance started in 2005 to use them.
Okay, and did they consistently use it, or when did they not use it?
No, they used it for 8 and they didn't use it for 12.
Okay.
And the ones that they didn't use it for were the ones where there was evidence of mutagenicity and in assays they did use it, and it wasn't specific to the organ like we were talking that had tumors or anything. But when they didn't use it, they were like the chemicals that are called non-genotoxic carcinogens, where some chemicals cause tumors, and there's been a lot of mutagenicity and genotoxicity assays, and they're almost all negative. That's when they did not use it. I just wanted to make sure it didn't have to, it wasn't only for chemicals that were known to form DNA adducts or something really it's when there were similar levels of evidence as for chromium for genotoxicity and mutagenicity, EPA used it for those other chemicals, and it's consistent.
All right, thanks, okay. Because arguably they would have to show the chemical act through mutagenic mode of action, and then they would apply it. And you're saying that's essentially what happened here. But in some cases, they didn't apply it for whatever reason.
Because all of the genotoxicity and mutagenicity acid, those chemicals are non-genotoxic carcinogens that have been tested, and it was negative, so they don't apply it.
That would be very surprising. He's saying because they didn't have sufficient evidence on a mode of action. Because essentially, if they have enough evidence to conclude it's a mutagenic mode of action.
Wait, I'm sorry.
EPA hasn't concluded. There's only been 2 chemicals in like 15 years that concluded. It doesn't act through that.
I have to back up, I'm sorry. This has been said before. The slope factor approach is used when EPA concludes there's a mutagenic mode of action, and also when the mode of action is not known. For those chemicals, there was no evidence it was genotoxic or mutagenic, but they do not know how it's doing it, so they use the slope factor, but not.
So the 12 in which they didn't use it were one in which they were not able to identify the mode of action.
Correct.
So it was sort of a default approach.
Exactly.
Okay, thanks. Any other comments on the application of the age-dependent adjustment factors?
I have comments on the application, but that's in a different part of the charge question. So do you want me to talk about it now?
Is it you're talking a different part of Part B, or is it a different part of C or D?
D.
It's in C?
It's in D.
Okay,
I think, yeah.
Let's hold off
Okay.
until we get to D. Any other comments? So it would seem to me, and let me just say what they're asking us. So because of the conclusions that EPA, let me just read this, okay? Because the tumors in rodents and humans were observed in or proximal to portals of entry where cellular uptake of chromium-6 may occur prior to detoxification to chromium-3, and because a mutagenic mode of action for chromium-6 carcinogenicity is sufficiently supported in laboratory animals and relevant humans, EPA applied a low-dose linearity approach for both the oral and inhalation routes of exposure. So I guess the first question is, do we support simply their application of a low-dose linear approach, or do we recommend the way they go back and investigate some of these other potential mechanisms as influencing that linearity? That's the way I would look at this first part of this question. Does anyone have any particular thoughts? I mean, I guess the question that I should point out, and this one came up in one of the public commenters from the American Water Works or whatever. You know, the safe dose is estimated by linear extrapolation is, I think they said 35 parts per trillion. So this is well below normal natural levels of chromium-6 in various types of media. So this is gonna, if that's true, then we go forward. And that's just to point out there are consequences to these decisions.
Could I just clarify, because their comments they're not toxicologists, and safe dose, they're just, because that's like not a technical term. I think I believe they were referring to 1 in a million cancer risk level. Well, some people, some agencies use other risk levels.
It's not necessarily
just wanted to make sure everyone knows 1 in a million is what they meant.
So I mean, that's it. John?
Just a point of clarification on the overall process. I thought I heard maybe it was Sue but somebody talk early on, that economic feasibility comes in later in this process. So this is purely science, and the financial cost of the water changes.
Not appropriate for us to
I totally agree that they did the calculation of the 1 in a million level in drinking water from the slope factor, right? But we're not supposed to, because we do this in New Jersey. We have separate groups that do the health effects and other things, and that's what we're supposed to do here.
So I recognize that the economic costs are independent of what we're doing, but the risk associated, 1 in a million risk, is very appropriate. Because if that's the virtual safe dose, I mean, you say that's what we're essentially the consequence of what we're recommending. And that is not separate.
Somebody should check that.
Okay, well,
before it's probably right, but before we take it at face value.
Yeah, it may not be accurate. I mean, I didn't go through, I was going to do the calculations to figure out what that is, but that's something EPA can deal with. They deal with this all the time.
Right.
So, I mean, in essence, we don't have to worry too much about it, but it's just be aware of that consequence.
I just want to note that the MCLG is maximum contaminant level goal, and that's 0 because it's considered there's no safe level for carcinogens, so there's not a virtual safe dose. EPA tries to keep the risks no greater than 10 to the minus 4. They may not be able to here, and so then they need to deal with the complicated risk management decisions that we're not having to consider.
So, Dr. Beck's correct for the drinking. This isn't only going to, even though a lot of the focus is on drinking water, this is a slope factor and a reference dose and an inhalation. All these factors are going to be used if it's found in soil or other media. And so, or groundwater quality standard, or ambient surface water quality standard, ambient water quality standard. It can be, for the Safe Drinking Water Act, for drinking water standard, if something's a known or likely human carcinogen, if it's classified by the weight of evidence, EPA's policy is that the MCLG is 0, and they try to keep the final number, which is based on analytical treatment and cost benefit, at no more than 10 to the minus 4th risk, and in the range of 10. But these factors, like if there's a groundwater quality standard, it's based on, at least if water's that's designated for potential potable use, that is based on drinking water exposure, and in different states use different risk levels, but New Jersey would use a 1 in a million for groundwater quality, and we would, you know, if the 35 parts per trillion is correct, or the soil standard or whatever. So it's not just for drinking water, but that's how these IRIS factors are used by states and EPA, but we're just supposed to do the science here and not worry about it, right, like we said.
All right. Sorry I brought up this complication. Ivan?
Yeah.
So-
John, go ahead.
No, I'm comfortable with where we were before, that the low dose extrapolation, they need to consider nonlinear toxicokinetics and justify their final approach in their low dose extrapolation process.
I agree with that. I'm glad I let you go first.
I guess we can go on.
Well, I guess should we take a vote to say how many would recommend to the EPA that they examine sort of the implications of sort of toxicokinetic factors on linearity before finalizing?
Sure, if you're comfortable with wanting a vote, I'm good with that. Sure.
Are you referring to both oral exposure and inhalation?
I think probably the focus would be on oral at this point in time. And
So should we take them separate vote?
should we look at this separately for inhalation versus oral?
I
Sounds
have
like there's a
a
few.
question, because this isn't something I'm familiar with the research and stuff on. Is there data that is available that can be used to do this in in developing the slope factor or data? I mean, the concept that it could be not linear at low doses due to toxicokinetics, but are there actual data where they could make that quantitative evaluation and base it on it? I don't know.
To some degree, they've done that. I don't know. You want to?
In my way of thinking, that's just why we're asking them to consider it. We're not telling them to do it. We're telling them to consider it.
Yeah, so I mean, there's always new studies coming out on this, and there was a paper in 2020, I think by Wang et al., that showed even at very low concentrations in an in vitro system that they built to examine reduction, there was still, at pH of 3, it was, chromium was escaping, their hypothetical stomach at about 20%, which is kind of consistent with our models. But then at the pH of 1.7, it was close to 0. So it is something that we can maybe flesh out a little bit more. Like Anthony said, I mean, if there's a zero order process at a certain pH, then it might not matter. So, I mean, we could just expand on that a little bit.
And so, Dr. Post, I mean, all my figures and tables and graphs and whatnot, I mean, they're based on, actual target tissue concentration data, right? So, like I mentioned earlier, use of, even those data, the data that I analyzed and used resulted in better model fits for various endpoints. And so, there are some data out there already that have been examined.
So I think we have really two options at this point here. One is to recommend that, to agree with the EPA and say, go forward with a linear extrapolation, no further work is needed. Or the second one is to say, go back, re-examine this to see if the additional examination of sort of kinetic factors will change your interpretation of things. Does that seem like a reasonable?
Well, we need to specify for oral or inhalation, because I don't think inhalation exposure is in question here.
Okay. So yeah, I mean, I think let's do it separately for inhalation and do it separately for oral. Is that, people agree with that? So let's start with inhalation first. Oh, sorry.
I was going to say, I had a question about the oral proposal. Is that under the assumption that EPA is using, it's under the assumption that a mutagenic mode of action is being used, right?
Yes, it is.
Okay.
So if people are in agreement, let's show by raise of hand. Those who recommend the EPA go forward with their conclusion for inhalation risks following a linear low-dose model. Can you show? So it looks like everyone's in agreement with that. Okay. Yeah, that was for inhalation. Okay, then. So, and the similar one, now there'll be two options here. One is we recommend EPA go forward with the oral risk estimates using a linear model, or the two that the EPA re-examine possible influence of toxicokinetic factors on that risk estimate. Okay. Dr. King?
Sorry, I've been hanging on this conversation. I think it's fascinating, but I think the way you phrase that is going to be really important, because...
Unfortunately, I don't think I can repeat what I just said.
The reconsideration versus alternative consideration, I think, is one of the things I've heard you offer as sort of a midpoint in the oral in the oral ingestion route, because there's certainly a standard already in place for the low dose linear approach. But you're saying at one point you said you would encourage considering the mechanisms that might deviate from that. That doesn't preclude the linear slope, but offers a comparison instead, and replacing, which is what I heard you say just then in the motion.
I guess my thinking is I would send it back to re-examine, and if they felt like they could come up with a better approach using a nonlinear, if they had the justification to do that. But if they went through this and couldn't come up with a better approach, then they would use the linear. I mean, that's kind of send it back to them saying, we think this should be re-examined, but what you've done is consistent. What they're doing currently is consistent with their guidelines. We're just saying, can you do it better? If you can, do it. If not, use your guideline. John?
You think we could ask him to come back up here and ask him if he's already done this?
Can I clarify before we ask, I'm kind of confused about what we're considering. So I think we're not saying that there shouldn't be, it's the thing that we're asking EPA to possibly consider still like a slope factor, but it would take toxicokinetics into consideration. So there would still be like a risk at any dose, but it would adjust the risks at, the dose at which certain risks are estimated would be different. Because when we're talking, the word nonlinear also means a threshold approach, which is the other mode of action. And is that what we're talking about? Or are we talking about like a toxicokinetic adjustment in calculating a slope factor, which still like is, whether it's, I won't call it nonlinear, but a no threshold approach? That's what I'm confused about. Does my question make sense, or am I the only one who's confused?
No, Dr. Post, I mean, I proposed an approach like that in my comments. And, the subject of my first paper that I published was the derivation of dosimetric adjustment factors to more accurately predict excess risk at doses below the point of departure dose for the draft oral slope factor. So anyway, it's something that could be done, and it's a non-linear approach that still assumes some risk at any dose. And then I carried that forward into my last paper, where EPA is free to address it however they want to. I fit a model to that sublinear curve, and so that excess risk could be estimated just by plugging your oral dose into a function. So
I understand. I just think we have to be really careful, because the word nonlinear is often used for, in this context, is a synonym for threshold approach, and that's not, we're saying maybe we should talk about, like Mr. Haney said, a dosimetric adjustment or something. It's still a non-threshold approach, but taking toxicokinetics into account, and that we just have to be really careful with how the word nonlinear has different meanings here.
Sure. Ivan, did you want to?
Yeah, I wonder if we need to kind of put something on the screen so we all understand what the considerations are. I sent some suggested wording to John just because he's on Zoom and I'm not, so I cannot connect my screen. So is there a way maybe for us to, word or at least see what the, what the vote is on? Because Dr. Eastman, you already...
I fully agree with you.
Okay.
I mean, and even the wording on that will be a little tricky, but...
So maybe we can postpone when some people are writing this, and then we can move on and return back.
Yeah.
I sent, Yvonne, I sent that email to Sue with suggested wording.
Is Sue, are you on Zoom?
Yeah.
I am not on Zoom, but I can send it.
Okay, John, if you can maybe share your screen.
Oh, Lord. That requires some technical expertise here.
In the middle bottom of your screen, there is a green button that says
Share.
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 Push on it.
I did. I pushed on it. It says it's disabled. Host disabled for screen sharing.
I was just going to make a quick comment that if we say sublinear, people will not confuse that with nonlinear / threshold.
I mean, my approach is I would say to the EPA, model this and come up with your best model, and if that says threshold, use it. If it shows some other thing, use it.
But that would be in the part where there's data, and then it would still be a linear extrapolation from the end of the known data to like the 0 where the 1 in a million risk and 1 in 100,000 risk are correct? Or
Well, I mean, I guess you're talking about modeling within sort of
it's more to
determine
get to
a point of departure.
right. It's not modeling the part. It's still a linear. It's really the determination of the point of departure. Not we're still using the linear model from whatever the point of departure is to the risk. I think to the
No.
0.
No, that's the point.
They would look at the implications of what they come up with into the very low dose region.
I don't know.
Dr. Post, what I'm showing in my figures and tables is below the mouse oral slope factor POD, and that's the whole point of it.
Wait.
That as doses decrease below the mouse oral slope factor POD, that you have decreasing fractions for the dose that's being absorbed into target tissues, and you can model that. But so for example, there's about a 4-fold difference between the actual target tissue dose and that predicted by linear low dose extrapolation. So, I mean, the only place that it's important is below the POD. So, but you can model what the sublinearity is below the mouse POD, and then use toxicokinetic adjustment factors to adjust your excess risk calculations.
So model.
And so I think that's what we're talking about.
Dose at lower doses than we have data for. Is that what we're talking about? Is that correct?
So as part of the MOA study project, they exposed female mice to various drinking water concentrations, including 2 doses below the carcinogenic doses in the NTP studies to get a handle on this. Well, to get a handle on those data. And then when I looked at those data, I identified apparent decreases in the fraction of dose that's absorbed as doses got lower and lower. Okay. And so there are some data that can give you an idea of what the curve looks like, and since then there may be new data that help with that, or maybe those data can just be modeled, and then you'd be able to predict that with some confidence. But given that there are dose dependencies in the dose fraction absorbed and retained in target tissues, it seems like the toxicokinetic portion of it below the POD is not something that should be ignored. It's something that the guidelines recognize the importance of, and it's something that appears to be inconsistent with linear low dose extrapolation. So it certainly seems to me that it's something EPA should assess.
Okay, sorry, I misspoke when I said like linear from the POD. I guess what I should have said is we only have data on the fraction absorbed down to a certain dose, which might be below like the tumor data, but it's not down to those really, really low doses. So are you suggesting that be modeled at lower doses than there's data
Yeah, it's so the data I looked at, and again, there could be new data, goes down to the MCL. So certainly toxicokinetic differences between the point of departure and the MCL are important.
The MCL,
And so,
current
and
MCL
so,
isn't really relevant to this discussion at all. That's an old number that was from a long time ago, and I don't think before any of these studies were done that, I don't see what relevance the MCL has to anything if right now.
well, it's of interest. You know, what the excess risk is at the MCL is of interest, and see where that falls in comparison to EPA's acceptable risk range.
Using
But it's of interest because it gives you an idea of how the toxicokinetics differ with target tissue absorption between the mouse POD dose and doses like the MCL.
I think we're talking about how to use this data on if there's a decreased absorption as the dose decreases to develop a cancer slope factor. So that's why it would be extrapolated down to, you know, to use the line that goes from 0 up. So that's what I'm asking. Would it be whatever the lowest dose that the data from the experiments is, it's going to be, the curve is going to be lower than that for the slope factor development. And that's what I'm saying. Would it be modeled from lower than the lowest data, or would we use that like then a line just straight down to 0 from the lowest data on the absorption? It's all very unclear. Maybe it's just me.
I think that decision would be up to EPA, but I think that they could use the data that's available to model it. Anyway, as for me, I looked at the actual data that went down to the MCL, and then I modeled it to a threefold lower dose than that, which helped just define perhaps the curve a little bit more. But I think Dr. Sasso could easily model these data.
I think we're really we might be getting a little downstream. I think we're just asking EPA to consider this, right? And they may decide it's not appropriate, but we're just asking them to consider it. I see the things on the screen.
Yeah. Well,
I wonder if we could add something about toxicokinetics in the second one. Provide additional justification for using low dose extrapolation, particularly with respect to toxicokinetic considerations, something like that, because that's really what we're talking about.
I would be a little broader and say, consider the implications of toxicokinetics as part of the linear low dose extrapolation.
That's good with me. I like that.
I mean, I would even leave the linear out, just as toxicokinetics is part of the low dose extrapolation.
Yeah.
Consider toxic. I agree with what Dr. Eastman just said, that they should consider toxicokinetics in their low dose extrapolation for cancer risk.
And then let them figure out the implications. And
is this
so the linear would be deleted on that second one, at least at this point.
And using linear should be taken out.
Well, yeah.
Are we all good with that?
Do we need options 3, 4, 5, and 6?
No, I'm trying to make it only one.
Well, Dr. Morris, I would like to just point out, and for your second bullet there, do you recommend EPA considers using toxicokinetic considerations in low dose extrapolation for the oil route? Well, if I were EPA, I could say that I've already done that, because they've already said that they used as a dose metric that portion of Chrome 6 escaping stomach reduction. Well, that's a toxicokinetic consideration. And so although it would go against the spirit of our recommendation, it could be said that EPA has considered toxicokinetic considerations, being that portion of dose escaping stomach reduction and their justification for low dose extrapolation. So I think more specifically, perhaps what we're talking about is considered using the data that exists on target tissue absorption, and even that table C10 outlines uncertainties with it, which are probably a part of the justification for not using it in the first place. But it seems to me that this needs to be explored with analyses, because and that this recommendation needs to be rewritten to be more specific about what we would really want them to do.
Well, I think the text will be more specific.
Oh, sorry.
I'm not worried about the EPA. They will act in good faith. How about just, do you recommend EPA further consider using toxico considerations rather than getting entirely specific? I mean, your comments will make it through. The comments will make it through about what we're talking about. I don't know that we need to capture them all in this simple statement.
But I'm struck by what Mr. Haney said about EPA has already considered that. I think we can make it more specific. Do you recommend that EPA consider dose dependency of chromium absorption as part of the low dose extrapolation? Because that's really what we're talking about.
Yeah, I'm good with that.
I like that a lot.
I like that.
Well, I don't, because there is no data on absorption. There is only data about retention.
Okay, retention. Got it. And we want to say, be sure to
Dose
say
dependency, yeah.
dependency, right. I don't know that we need to say toxicokinetics. I think we can say dose dependency in Chrome 6 retention. Yeah, I guess.
I just have a quick question. So I'm assuming this applies both to the small intestinal tumors and the oral tumors, because, I mean, we'll have to consider that for oral tumors too, when there's no reduction, it's direct contact and all that kind of thing. So, so will this question, also be applicable to the oral tumors? And should that be in there? Just a question.
That's a good question. I think we're specifically looking right now at the mouse small intestine, whether we talk about the rat oral cavity tumors or not. Do you think it's worth?
I mean, I would definitely look at, consider looking at both, because if it's, you can't ignore a tumor. I mean, there's an oral squamous cell carcinoma in the tongue at the lowest dose in in the male rats, and that's like, that's something we don't discard.
Okay. I mean, I do agree you have to consider it for both. You might say there's nothing you can do about it for the rat, but I think that to be balanced, we'd want them to consider it for, I would recommend considering
just
it for
oral
both.
rat?
Yeah.
Okay, probably both, I think.
So for that modified one, so it's not chromium 6 retention, it's just chromium. There is no chromium 6 at this point. Chromium 6 was exposure, but what's in the tissue is chromium. And our discussion here suggests that maybe instead of retention, accumulation would be a better word, but that's open for discussion.
I think it's more clear to me. That's
Do we even need to specify, the words target tissue in there someplace?
I think that's understood pretty much.
Whatever target tissues are for the oral route, that EPA will figure it out.
Yeah.
Dr. Morris, you want to lead out on this? You want me to?
Oh, I'm happy to. You know, what the heck?
Are people happy
I
with-
suggest we vote on the second bullet first.
Okay, I would agree too.
Yeah. So, all those that support the second bullet,
Now
please
it's
raise your hand.
First bullet first.
He
You keep
okay.
rearranging them.
Okay, hold on.
How about the bullet that includes toxicokinetic considerations, which seems to be the first bullet right now?
I thought we were taking toxicokinetic considerations out and replacing it with,
I think we can just say dose dependency.
Right.
Yeah.
Okay.
But I think there are other toxicokinetic considerations that might be considered.
they're already considered those,
Well,
some of them, not all.
I would leave it in because it gives them more flexibility and so just,
I was going to say, we could say IE instead of EG.
I have to look up every so often, make sure I understand those.
And it should be considered, consider, not considers.
Further consider.
Further, because it's a singular noun.
Consider,
Further, it
should further consider.
recommend that EPA consider,
Further consider. All right.
yeah.
I think the argument is they have done some already, so further consider makes some sense.
Yeah, I would keep the further in there. Does no harm.
Okay.
Are we done wordsmithing? All important to get the right words in there. Okay. All in favor of this recommend EPA further consider using toxicokinetic considerations in their low dose oral exposure? Please raise your hands. Only one, sir. Okay, I can't see around the room.
Okay, everybody except one.
Okay. Then we'll go to the next one. Do you support the rationale for linear low dose extrapolation for oral route as presented, or route as presented? All in favor, please raise your hand.
And I mean, assuming that it's a mutagenic mode of action, the answer has to be yes.
I mean, the EPA guidelines still, talk about the importance of toxicokinetic considerations and acknowledge them as a reason for non-linear dose response, and talk about the importance of considering all the data available for an assessment. So from my interpretation of the guidelines, just because it's a mutagenic mode of action, you're not forced to do linear low dose if other data indicate that there should be non-linearities. That's my interpretation.
Dr. Beck, did you say that if you believe there's a mutagenic mode of action, you'd have to vote for the second one, or did I misunderstand
I
it?
would say that if there's a mutagenic mode of action, the default is linear low dose extrapolation.
But this would be like using a you would assume it's linear based on the amount in the cell, but it's amount in the tissue, but you're making some kind of adjustment, chemical specific adjustment for how much gets into the target tissue, but then it would be linear, I guess, based on how much is in the target tissue. Makes sense?
Yeah,
Okay.
so this is like an either or.
Yeah, it doesn't, I don't think everybody who supported the first one supports that there's not a
Right,
mutagenic mode of action.
Okay, good point.
Okay, I think we know where we are here. And Dr. Eastman, you can come up with draft comments based on this, and I think that the one person that feels differently should probably send you comments explaining why they feel differently.
No, I just feel that everything's good. So my answer is the others need to explain. So I don't need to explain anything.
You lose, Yvonne.
That's right.
You can say that, but you bought yourself the chance to write a paragraph.
Right, and so just to add on to what Dr. Post said, once you get to target tissue dose, right, if you will, or retention accumulation, once you get to target tissue dose, then the assumption is linear low dose from there. The issue is nonlinear from oral dose. So nonlinear from oral dose, linear from based on target tissue dose would be the assumption.
Okay. I think we'll
We're really
see
just
the
asking EPA to
draft comments
consider
that
this. We're
Dr.
not
Eastman comes up with.
saying they must do this, correct? We're asking them to consider it, but not saying they must change everything if so.
I believe that's the impression. We're just asking them to consider it, but they don't. They can go forward using their best judgment.
Let me just jump in here. Are people starting to hit the wall? I'm getting a sense we might be. We have plenty of time tomorrow to do the last three and then summarize, or do you want to press on?
I'm happy waiting till tomorrow.
Okay. I can go either way.
If you don't think there's enough time to do justice to C in the next 45 minutes, then I think we can hold off until tomorrow.
Yeah, I think, yeah, who knows? We might get hung up again. Let's do that. Let's hold off till tomorrow because we'll have plenty of time and we won't be constrained by concerns about time. And I also would suggest that the lead discussants, if you have any questions, burning questions about consensus relative to your tier 1 or tier 2 comments, feel free to bring them tomorrow while we're all together. And we'll try to discuss them. If you're good with what you have, then you're good with what you have. As far as I'm concerned, we can adjourn. Sue, are you okay with that?
Yeah, I don't know how I'm quite going to pull all this together, but we'll see.
Well, you're earning the big bucks.
I can summarize what's happened in the key points. Some of the sort of additional supplemental information will probably go into an appendix or something. But anyway, I'll do my best, but I'll think about it. If I have questions, I'll bring it up tomorrow.
Yeah, we'll have plenty of time.
Yeah, tomorrow we'll have plenty of time to complete the discussion for charge question 6, as well as any lingering questions from lead discussants wanting to make sure that they understood what was being advocated and recommended by their colleagues. So we can go through that a little bit.
So are we supposed to develop something, if we can, that's consensus, if we're the lead discussant? I wasn't.
If you have any lingering questions, if you feel comfortable with what you heard today and you understand where the panel sort of goes down on what is tier 1, what is tier 2, and what is tier 3, then we can work on that
I'm not
after
sure
the meeting.
We tried to get consensus on my question. I have to go back and look. So if I have questions about that, bring it up tomorrow.
Yeah, if you have questions and if you need input from other members, then please do bring it up tomorrow. I think we'll have enough time to work on that as well. Okay, so we have a few extra moments of time today, and so we'll recess until 9 a.m. tomorrow morning. Thank you.